All right, we'll be starting shortly. I'm just making some tea, and then we'll rock and roll. I'll put up the title, the subject today, which is building a Go agent framework. I think it's going to be pretty dope because I found this pretty sick pattern that this framework Pocketflow in Python manages to do in 100 lines. So we're gonna dive into that. And let me see. Can I just move this up? Yeah. So I'll be back in a couple of minutes. All right. Hello. Hello. We're going to be streaming building Go agents tonight. We're going to be using Amcode. We're going to be using Cursor. We're going to be using ChatGPT probably. And I've been playing around with the idea of a framework for a long time. Like 2 years ago, when LangChain started, I was like, that's the wrong abstraction. I'm going to build my own. Tried to build like a crazy monad system, which then I tried to build again. Kind of didn't fully pan out the way I wanted. And I've been like messing around trying to find like a good way to build agent frameworks, like especially so you can compose agents, yet also deploy them at scale. And I finally found the pattern, which is this Pocketflow agent framework, which we're going to be looking at. And we're then going to try to build in Go, maybe tonight. I don't think so, but we'll try. So let me show you what I'm talking about. I'm talking about this Pocketflow framework here, which is a 100-line Python framework, which is pretty cool. It feels like 2009 again, where we had JavaScript framework after JavaScript framework after JavaScript framework, each one being like, we'll do it in 100 lines, we'll do it in 50 lines, we'll do it in 30 lines, we'll do it in like blah, blah. And at the end, we stuck with like React and stuff. So I think what's nice about 100-line frameworks is that they allow you to really pull forward the essence of what a pattern is. And I was bringing up the idea, for example, when you have a load balancer, the idea of, say, a round-robin load balancer is to go from one bucket to the next. And that code has to be fast, right? Like a request comes in, you want to immediately find which server to route it to and send it out, which means the code has to be short for it to be fast. But if you look at Nginx, for example, it's like thousands and thousands and thousands and thousands of lines of code. But if you look close enough, there's going to be this one little line that does the round robin thing. And all the rest is like logging, configuration, startup, all these kinds of little things that actually turn something that's 100 lines at its core into something that's like 500,000 lines, right? So super great project. I don't know. I wouldn't use it in production just because I don't like Python. I'm sure you can. Okay, this looks nice, right? Like you can add all your like instrumentation stuff around it. But we're going to be looking at the core here, investigating it a little bit, and then trying to convert it, because it's not an event-driven framework. We're going to be trying to convert it into an event-driven system. I made some pretty nice little slides, so I just ask, well, I didn't make little slides. I had, of course, ChatGPT make me some slides. I haven't looked at them yet. Well, not too closely. So we're going to discover them together. I just had them render into Obsidian slides. So we'll see what happens here. We're going to create a note. Today we're the 15th. And we're going to call this Go Agent Stream. And I'm going to paste my slides. Come on. When is the VI mode going to kick in? There we go. And then if man, there's all this stuff going on. If I start the slide stuff, I think, holy shit, come on. And then I think I can open this in my browser. Right, here we go. So we're going to be reimagining Pocket Flow in Go. I'll go into a little bit what an event-driven pub/sub architecture is and why it's, I think, a perfect fit for agent frameworks. Well, look at the builder pattern and how to use the syntax that we can't really do in Go that is possible in Python and actually port it over to Go. And I think a builder pattern is something that works pretty well. And then I guess live, we're going to be trying to code it. We'll see. One of the examples I really want to build is the supervisor example, where you have a supervisor node in the agent that does some inference and based on the response routes it to another little agent. And then we have, let me see if there's anything in the chat. No, there's nothing in the chat. But yeah, and then the final one is like the design walkthrough. Like, I don't think that makes any sense. It's like some weird LLM stuff. So what are the takeaways? See why pub/sub is cool. I really recommend looking into this, and I'll explain why I think it's like particularly important for LLM applications. And we're going to see how we can, even if we don't get to implement it, right, we'll get into designing the API. And I think designing the API, whoops, that's not what I wanted to do. Designing the API is kind of the most important part, right? It's like if we design an API that doesn't work for us and doesn't work for the LLM, then it doesn't matter how it's implemented. It's just going to be like tedious and problematic in the long run. And this API should allow us to do some of the more complicated things that make up an agent, which is branching. Dynamic branching would even be the coolest thing. Looping, doing things in parallel, right? Like doing calls in parallel. And I'm not sure what surface pipelines even means. Probably means something clever that I don't know about. And we will be using, I don't know what HTTP APIs means either. We're just going to delete this very quickly after that. And then Watermill is an event-driven framework for Go. So sorry about the AI-generated slides. I should have, well, I was exercising before, so too bad. You'll have to deal with LLM slop. So this is a little bit, we'll go into this. This is probably not a good slide. And well, probably at this point, the slides are not going to do us any favor, I think. So we'll stop here. And why didn't it continue copy pasting this stuff? Oh, because it was continuing here. Like one day LLMs will be able to write Markdown correctly. The day is not here yet. So let's look at Pocket Flow. These are the 100 lines that make up the Pocket Flow framework. And you can see I'm just looking at the class names. Like, I don't care about this right now, and it looks like very small and cryptic, which makes even less sense to look at too closely at first. We can see we have nodes. We can see we have flows. I guess a flow is also a node. That's interesting. We have a batch flow, whatever that means. We have async nodes. We have async flow. We have async batch flow, and that's it. Are you like, what does that even mean? How is that a framework, right? And that's what we're going to get at looking at examples, right? Like this doesn't tell us very much. So in a way, we're kind of like LLMs as well. We don't care about what's under the hood in as much as we want to have something readable that explains the purpose of a program at the surface. That's why we have programming languages. That's why we have APIs. That's why we have all this like clever stuff we designed over the years that's becoming more and more obsolete. But actually, it's not obsolete. We want to state a problem very clearly in a way that a human or an LLM can unambiguously do what we want it to do. So that's what frameworks ultimately are all about. That's why my stuff didn't work out so well. And that's why this one is really interesting, because if we go into the cookbooks, right, and we're going to take a very, very simple example here, it's going to be a very simple chatbot. So let's actually go look at the README, and we can see the chatbot basically, you say something and then you say like continue. So this bot is going to be chatting with itself, I think, if I remember, or it's taking user input and then it sends the complete conversation history, right? Like that's what makes it a chat, is that there's a history of messages being done one after the other. And once a response comes from the LLM, you append it to the history, you wait for the user input, you loop back. So nothing crazy here, right? We're going to look at the main PY. So we have a chat node. Going to skip over it for now, because we're going to look at, again, at the top level, right? We're going layer by layer. And so if we look at the start, we're starting a flow. A flow is, interestingly enough, just something that starts at a certain node. I actually don't know why this is not just plain node, but we'll see. Now we see we create our chat node. Okay. And then we have this weird syntax here. We have like chat node minus continue gets into chat node. So this is doing something I'm not too fond of, which is overloading operators. I'm not too fond of it because it often makes it hard to go to the definition, right? Like if I want to go to the definition of this thing here, it's like most IDEs are like, I can't. And then it also leads to like weird, I think, I don't know if LLMs do all too well with it. I think this is a simple enough rule, but often minus in the training corpus is like associated with subtraction. And so I'm not sure, or like subtraction or like all kinds of things. I'm not sure if this is, it looks pretty, so we'll go with it, right? Like it looks pretty. And then we're going to try to understand, what does it mean that like chat node minus minus continue goes into chat node? And so the concept behind the framework here is that you're going to have a prep state for each node. And when this prep state gets run, it returns, hold on, what does it actually return? No, sorry, when the prep state step has some shared state that gets passed into it, it can modify the shared state, which is shared, I think, across all the nodes and belongs to the flow. We'll look at that more closely. It can modify the state and pass it on to the execution step. At the execution step, this thing does something. Often it does call an LLM, but it could be calling a database. It could be like doing random or just like returning a fixed string. This response is going to be a string, and this is the string that's going to route to the next node, right? And then I don't remember what the post is. We'll look at that. So this is, I think, roughly how it works. I didn't explain this very well because I forgot how it actually works. So we're going to look at the documentation. Very good. So we're going to skip all of that stuff. We're going to look at all the, we're going to skip all of these little things because we're going to look at them later on. And so how do you use it? There's no documentation here. Where's the documentation? How does it explain it? I actually, literally what I did was to go to Deepflow. So the core abstraction we saw here, right? Like nodes handle simple LLM tasks. Flow connect nodes through actions. That's the labeled edges. So continue was a labeled edge from the chat node back to itself. And then there's a shared store, which allows these different nodes to exchange data. And that's something that's going to be interesting in our event-driven architecture, is that in the event-driven architecture, different nodes are going to be potentially running on different machines. We're going to keep it simple and have them run into the same program, but that's going to be an interesting thing because at scale, if you're running on like different machines, you can't share state all that easily. And so the design pattern is whatever we're going to skip over that. We don't provide any built-in utilities. That's cool. And I think that's like kind of the whole thing over here. I don't think it describes how prep and all of that works. So it gives you a ton of examples. And I think that's really, really cool. And here's like the supervisor example that I wanted to show. Is it the supervisor? But there's like a node that decides what action to do next. You can see here in the execution step, it will get its inputs, which it gets out of the shared state on the query. So there's going to be a node that puts in like the query in there. It calls the LLM, parses the output, and then based on the output, if it's search or answer, it will go to a different node. And then the post, I'll have to see what the post is. I think the post is to just update the shared state for the next iteration. I'm not fully sure. We'll have to see. The search web node literally just searches the web, taking the shared search term. And then after, yeah, it just updates the result of the execution. Okay, so the post step takes the shared state, the prep result, the execution result, and just updates. It can update the shared state, and then it returns which edge to take. Okay, so that makes more sense. So if we recap these things, and we're going to make a new file. So this file is going to be called 2025-15 Go Agent Stream Notes. The pattern of our agent here is agent, or like node runtime flow is going to be first run prep on the shared state. So this is extract compute information out of the shared state. 2 is run some operation that does the main work, call an LLM, etc. And I think, and then 3 is going to be post-process shared state plus result of prep step plus result of execution step. Post-process returns the name of an edge, which will do something. So what happens with this resulting edge is the next thing we're going to look at. And now I'm going to show you something cool, which I'm sure for the deeply connected people that are out there, if you replace this with DeepWiki, you get to the Devon page, which allows you to go to this DeepWiki page, which has analyzed the whole GitHub repo, which is a hit or miss quality, right? Like it might just like latch on a part of a big repo that has no real significance. But here we can kind of see a node lifecycle. So we get the prep result, we execute it. There's a retry logic, interesting. So we'll see how they do that in 100 lines. Then we do the post-processing step. It returns the action, and then the next node gets triggered, I guess. And so the flow is probably the thing that operates dispatching on this execution, right? And the rest, like the problem with DeepWiki, I think, is it looks really good, right? Like as far as these sites go, it's the best one that I found. But it can be misleading because you don't know why the slop has appeared, right? Like there's a lot of slop, and it might be that the slop actually misleads you into understanding what the repo is. So it often makes the most sense either on a repo you already know, and then you can like quickly ignore and navigate whatever's irrelevant, or if you are actually asking the questions and creating the slop yourself, right? It's like, it's always nice to read your own LLM output. It's really annoying to read other people's LLM output. So to tackle that, what I have always done and continue doing, because it's really fun, is that I will just clone Pocketflow, right? And then I'll just open it in Cursor. Oh, and I have like many cursors open. So let me quickly close that. Don't save. Close this one. Don't save. And then we're going to open, where do I open? Open folder, code, others, LLMs, Pocket Flow. I'm going to open in Cursor, not save my workspace. Going to be in here. Going to open in Cursor, right? And then we can do questions of like, how does the result of the post step in nodes get handled? Why is it even there? Like, that's a question I'm asking myself right now. I'm like, oh shit, I forgot how this works. I better figure it out. And so either you can experiment with having it find the right context, and that's really important, or like a really interesting way of figuring things out is like just see where something like Cursor or another IDE that is like good at looking for context, what it's going to do, which often is just like grepping for strings. But Cursor does an indexing of the database with like vector embeddings, which might be interesting to look at. I think things like mcode will just use grep. So we'll compare the two, right? Like since we're in experimentation mode tonight, and I told people I was going to experiment with mcode, might as well burn some credits here. And so while it's generating the agent file, I'm going to drink a little bit of tea. So you can see it immediately found like the right file here, because that's the whole framework, right? 100 lines. I don't know if it read it just because of the init, but I think it just like read it because it's the only import here. My guess. I have no idea actually why it did that. Let me check for existing rule files. So I think this is kind of hard-coded. It found like a bunch of Cursor rules. That's interesting. I didn't see those the first time. So if we look at what the Cursor rules are, they're actually longer than the code itself. And this is maybe why DeepWiki did a pretty good job, is like it just found basically what it's displaying, right? So this is kind of like exactly what we were looking for, which is each node's post returns an action string. By default, if post doesn't return, we treat it as default. And then we define a transition with the syntax, blah, 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 which we saw, right? Like it's this minus going into the node. But then I still wonder, like, what does flow run do? And so here, I guess we have a graph. So the approved state in a little branching loop, if we look at it, can return like a bank transaction. I hate this. Approved, needs revision, rejected. Here, I think what happens after that is that if review post returns approved, the expense moves to the payment node. I don't know what that means. The expense moves to the payment node. I think it will just like run that node. It will just like call node.run with the shared info. And then it follows the actions to the next node, so on, until the flow can continue. Okay, so it just like calls run one after the other. And this is going to be the tricky thing to port to an event-driven architecture, which is how do you say, oh, now let's move on to the next node, and how do we trigger it? And can we use certain events to do so? But also, if I imagine that I'm in an event-driven system, so in an event-driven system, and I should make like its own stream about it. So I'm going to assume that you roughly know what it is. And if you don't, like, quickly ask ChatGPT. In an event-driven system, you have a lot of little programs that basically wait for an event to come in. They have like a callback that says like, look, here's a data structure, do something with it. And then each of these little programs, after they receive like one of these data structures, they have the option to also emit some of them, right? They can say like, oh, look, after processing this event, I want you to handle these events. So for example, if you have a request event coming in, you can send a response event, for example. There's also systems that basically inject events, like for example, a cron job scheduler might say like, well, the cron job has triggered, like please, whoever wants to be triggered, like listen to this event. But there's also things like incoming webhooks, right? Like if you build like a Discord bot, you will get like incoming events from Discord, and then you can put them into your event-driven system, have it distributed to something that's called a publish-subscribe mechanism, or often depending on how you're building it, it's called like an event broker, which is like slightly different depending on how you interpret these terms that a publish-subscribe. mechanism. But so the idea here is like, if I have a node like the one we saw here, and I want to make it event driven, that means that the next node to be triggered has to be triggered with a certain event that causes it to work. But similarly, the execution step will be asynchronous, right? So in an execution step, it might very well be possible that I do something that's really just sending out an event, but then I have to wait for the response to that event to come in to then resume my execution method, so to say. So for example, if I have a chatbot and my node gets started, right? And I send out an event like LLM inference request or LLM inference command, which is a certain pattern that we'll look at, then I'm done. But the graph isn't done, right? Like the agent isn't done. It's only when there's either a timeout event that comes back or there is a LLM response event that comes in that I can continue doing things. So that's going to be interesting to see how are we going to build nodes that where even their execution method is actually asynchronous and depends on an event coming in. So I actually don't know how we're going to solve that. We're going to look at the different ideas, or maybe we'll let an LLM do the work. Like, who knows, right? So this is all good and great. We kind of found the documentation that we wanted to look at. So in a way, it's like a little bit cheating because if I ask this question, there's a very good chance that the LLM find exactly that file instead of reasoning about the core of the framework. So I'll show you different methods of doing this, right? Like there's always the danger that you want an LLM to do something, but actually will cheat and will find a file that looks like what you asked for and say like, all right, I'm done. So you do have to make sure sometimes that the LLM actually found the content that you wanted to find and works with that instead of potentially either making stuff up, which they've gotten pretty good at not doing these days, or just like finding something that makes it think it found the answer and then not thinking further, right? And that we saw some of these issues in the last stream on Tuesday, where I figured out what it did is like when it fetches a file from a URL, it only reads the beginning. And so for some reason, it found a how-to, which I wanted to use to have it do the thing in the how-to, but it stopped reading after 1,000 lines. And so the further steps of the process after that, it just made up the rest of the tutorial, and like it all seemed like it was making sense, kind of, but not really. And that like kind of kills you, right? So you want to be absolutely sure when you ask a question, especially an open-ended question on stuff you don't know, that it actually is looking at the right files. And that's why it's like kind of really, really important for models to, for tools that you use to actually show you what they're looking at. And that's why things like ChatGPT.com are kind of hard, because you might like to hide a lot of from you what they're doing. So it's always like a matter of being a little bit skeptical what tools like ChatGPT.com do. In Cursor and in AMP, it's like a little bit easier to look at that, and also it's easier to steer them, right? So we're going to do completely unsteered. I have no file name in here. I don't say much where things should go. I have a very unclear question. So we're just going to see what happens. And then we're going to ask the same question. And we're going to start with Claude 3.5 Sonnet. And I kind of wanted this to be a coding stream, but maybe I think it's always like kind of more important that I show these like techniques here. So this is interesting. I haven't seen this like new version of Cursor where it found rules. Okay, so it shows you the rules, which is pretty cool, because that means that it found, right? Like it found, oh, maybe it found the open rule. So that is the first cheating thing, right? It's like, oh, well, actually I had this all open, so that kind of doesn't make sense. So maybe I can do this, and I kind of want to remove this from the context, right? Like I don't want it to have that rule. I want it to have what supposedly is a completely fresh context and start. We don't really know if it's a completely empty context. I suppose not. I suppose there's some information, and then it still managed to find that node, right? Node and flow. I'm not sure why it found flow. We can maybe look at the file now and see in the MDC, is there something that indicates agent requested guidelines for using Pocket Flow, core abstraction, and flow. So maybe it found that this is a core abstraction. We'll see. I'm not a great rules user, so I actually suck at understanding how they work and when they get pulled in. Here we can maybe look a little bit at the thinking process. So I think this is Sonnet 3.7 thinking, which doesn't really output a lot of stuff. So it's like, yeah, I need to examine the code base on the node implementation of flow execution. Let me start by searching for core information. I wonder what this is. Is this like vector search? Is this a sub agent? I don't know what this little symbol is, but not sure what it does underneath. Like maybe as a tool here, I think there is like a code-based search agent. So I suspect this is like a sub agent that then allows it to like fold the context into it, right? So interesting prompt engineering. We'll get back to this once we have our own agent framework. But so let's get back to this one here. The post method controls node transitions. All right, cool. It returns none to follow default path or action strings to follow conditional path. This is the mechanism for directing flow execution on the node's operating result. That's not what I was interested in per se. I want to be like, yeah, what does it mean to be doing flow execution, right? So maybe that's what I'm just like put in. What is flow execution? I just realized I'm still logged into my work account probably. Whatever. So here we can see it found the exact same file except in the docs and not the rules. So I wonder how much of this is just duplicated. It does look pretty duplicated. So I wonder how they manage that, right? Like how do they manage to keep these things in sync? How do they manage to make sure that they're always up to date? I'm pretty curious. I wonder what the Git history is of these things. So that's always stuff that I am interested in. I'm gonna not do all of that stuff in AmpCode just because I'm more familiar, and also I think it's gonna be cheaper to do it in Cursor for this kind of stuff. So we're gonna start a new tab here. And what I'm gonna ask is like, what is the Git history behind flow.md and flow.mdc? How are they kept in sync? Do they get updated along with the framework? So those are questions you can totally ask because it can run Git in the terminal, right? And it's going to be clever enough to do so because I said Git history. So that will very strongly say like, well, I'm going to look at the Git history, which I do with Git log. So that way you can actually ask some pretty subtle things and like basically use this as your general purpose agent to do code base archaeology spelunking, right? And I'm going to stay with Claude 3.5 Sonnet because I don't know, it's like proven itself in the past. No need to be too experimental here. And we're going to try to start seeing like, what is it doing? What's weird is I link these files explicitly, so I don't know why it's searching for them. And we can recreate this a little bit, right? And here you can see, all right, it figured out the Git log. And pipecat, I don't know if this is something I put in my rules actually, so that it's now doing it consistently. The pipecat, is that something I put in here? Or is that something they added recently to not break the terminal? Because I had that rule for a while. It's just to help with escape codes and all that nonsense, to help it avoid blocking the terminal. So that really helps because it makes the STD out of a tool basically be not interactive. And a lot of tools, when they realize that their output terminal is not interactive, will behave differently, like not output colors, like not do some kind of 50 million tokens space, white space kind of adjusting. So if you have like terminal UIs, those will output a shit ton of escape codes. And funnily, I don't know why a shell history tool wouldn't like filter those out, but it led to just like huge discussions without something really interesting. So it's going to look at the Git log, which, it didn't like try to limit it. So this is a good way to burn through your tokens as well. I don't know why it did like -p like straight out the bat. Very wasteful. So we're gonna compare. Like this is 3.5 Sonnet, which is by today's standards ancient. And we're gonna, before I continue, I'm just actually going to show you my technique beyond just pressing regenerate. Here I do want to try out different things. So we're going to try out 3.7 Sonnet. And only then are we going to look at this. The content relationship, they're nearly identical. The one has the Jekyll front-end matter. Looking at the Git history, FlowMD is the source of truth that gets committed to the repo. MDC happens to be a copy that Cursor copies. The MDC files are not tracked in Git. Yeah, no, that doesn't make sense. That's like some kind of hallucination. So interesting. Interesting that it like kind of made this up. Definitely not what I was looking for, right? So when you have a situation like this where the model like kind of does nonsense, that's the great opportunity to start investigating why. And the first thing I'm going to do is just regenerate and see like, well, does this happen every time? Is this like something that was just a fluke? Is it? And then once I get a sense of like, how often does this happen? Is this something that happens reliably that I need to be on the lookout for always? Right? That's really good, actually. It sounds stupid, but if a model repeatedly gets something wrong the same way, that means actually that your prompt is really repeatable and it's a really good prompt. You just need to modify it. But if it's something that happens like from time to time, then it's like tricky because it means your prompt is probably pretty good, but you have to be on the lookout for stuff where it just like makes stuff up. And so we're going to see if there's a way. So the first thing is that it's not able to find the file by itself. So I think Cursor like filters shit out here. Might be my guess, right? So here, that's what I was expecting it to find, was to find a script that kind of updates the MDCs. And it looks like we found it here. And this one, I mean, obviously it's pretty funny because it's like 1,000,000 times bigger than the framework itself. What I was kind of looking for was like, well, I think they generate the rules out of their documentation. It doesn't make sense to have them like duplicated all the time. So that is interesting, right? It's like, now I have this general purpose agent that's like kind of like looking for files, grepping here and there. It's like it found the MDC PY by looking for the MDC, which is funny because this was like a bug and we have a completely different behavior than before. But now it looks at the Git log again, and I think this will like kind of lose it. I think this just outputs too much stuff and confuses the model a little bit. And now it says like, oh, well, like, so I already have something in mind for the prompting, but we'll get back to it. So this guy, the second time, found something that's really interesting. It says like, oh, there's an update Pocket Flow MDC PY, and I don't know when the script was added. It says like a month ago, and it's been updated since. The current implementation creates individual MDC files for each markdown files. I don't know when it's run, so that could be like a follow-up question, right? But let's see how often it is able to find that file, and also when looking at the Git log, start with just the commit and maybe a few content lines. Otherwise, we get too much info. And actually, this is 3.7 Sonnet, right? So maybe I regenerated wrong, but we'll see. This is confusing in Cursor because it changes the model on all the tabs. So I keep making stuff badly. I don't know which model this is running now. So this found the thing, and it's 7 Sonnet. You can see it did the head 30 here. So I didn't have to put this in explicitly, but I think this is not robust enough for it to be really strong. And that's the kind of stuff that's like hard to potentially prompt engineer, or you could just make it part of the run shell script tool to just say in the tool description, this is going to cut off stuff at 50 lines. Something like that. So I haven't built many agents, so I'm not really good at tool prompt engineering, but I hope I will. And what did this find out? The sync process seems to be manual. There's no automatic GitHub workflow. So this looks all pretty good, right? And this was 3.7, so much more interesting than the past. And if I were really in like experimentation mode, I would do like more and say here, because I prompted it to looking at the Git log, it will actually immediately look at the Git log. So this is the side effect of adding guardrails and instructions to your prompt, is that you will actually cause the model to do stuff that, right? It's like the do not think of an elephant, and then will like basically think of an elephant. So that's always like a double-edged sword. And then I don't even know what this is here. What? Why does it do this weird thing? Oh, does it have that internally? That is so weird. Do they just append that somehow internally? That is new behavior. So maybe that was what a dude on Twitter was like, they broke the terminal. Maybe that's what they were referring to. Jesus Christ. All right. Well, anyway, getting lost in the weeds here. This is really annoying. If you can just like run shell scripts anymore. Let's just see, just for fun, what AmpCode does out of it, since it is 3.7 Sonnet, and we're just going to give it the non-prompt engineered one. And see what it finds, right? So I found the update script immediately, which is crazy. Like, that's why I think that AmpCode has something special in their sauce. Is like, I'm not sure what caused it to do that. This one doesn't even have the full path to the files, right? Like because @flowmd is not the greatest for AmpCode. I don't think they do anything special here. Given that the user, oh, see, I was cheating. So that's the cheating thing. I was saying like, oh, AmpCode has something special going on. It's like, no, they just like looked at what I had open. Bad AmpCode. So let's try again without the file open, right? So we're going to see, and now they do the git log thing. This one's a little bit more clever about not looking at like 80,000 files. And then they seem to have found, how did they find the update? Create a script. So it's possible that they found the script and then that they have a list of the files that are related. Or is it possible that they found something in here? I don't know. But then I found the script and it just like basically told me that in like one paragraph. Like, I don't know. This is just like why I like AmpCode so much, is just like it just legitimately works better than the other things that I've tried. Like this feels very much like a normal LLM output. With a few tool calls ingested. This feels like it's just, I don't know how it's able to suppress exactly the right output, yet put the right stuff out. I wish one day I'll reverse engineer it. All right, so here we found this. This is actually not the question that I wanted to ask. The question is like, what is flow execution? You can look at the thinking tokens. This is too bad that it's not Gemini, because Gemini thought traces are really cool. So let's ask Gemini exactly this. Understanding the flow, how does the result of the post step and nodes get handled? We're going to keep this in the context. This is nice. And now we're going to ask Gemini Pro, what is flow execution? And maybe we should use the newer Gemini. I don't know. Let's try it. I've never really tried the new Gemini. And then those thought traces are usually pretty interesting. Here in this case, it's like not all that interesting. Based on the Pocketflow documentation, flow execution is a process of running a series of connected nodes starting from a designated start node. Here's how it works. Flow, then the flow starts, then it does the 3 steps, then the post method returns an action string. The flow looks at this, and I'm going to ask, like, find the code for it. So here the thinking are actually not that interesting. I'm going to ask something where it will think pretty hard, which is going to be interesting, I think. These thinking models work the best when you give them a lot of input tokens that they can correlate. Then you'll see them thinking a lot about like, oh, well, it looks like this function matches this pattern over there and it matches this. And then maybe in this file, there's that. So if you give them a lot of just like things to interweave, that's when they start getting interesting, right? And so now we're starting to have a bunch of words in our context window that I want to weave together. So my thinking here, if you go back to what I was saying earlier, is we want to turn this into an event-driven system, and the core difficulty of the event-driven system is going to be what if what is currently method calls is going to be split into an event sent and an event response. Is suddenly we can't just say like, oh, while true, go over each node and query this and get the result. And we have to kind of keep track. Which node are we currently in? The next time a message comes in, which nodes should I maybe send that message to? Or maybe nodes are always active and receive things, but when is one supposed to actually do stuff with it? So those are questions that are hard to answer. And we do want to have a lot of words written about runtime flow before we kick off a thinking model, or at least we want to kick that when we have that much information in there, we can start kicking off a reasoning model and get an interesting thought trace. If you start it off by itself, you have to wait until it finds all that. So that there's value in that too, because here we're going to strongly steer it into doing the same stuff than the current architecture, right? So I'm not even going to read all of this, A, because I'm on stream, and 2, because I don't really care all that much. But what I'm going to do now, and we have a thinking model, I'm going to say think very hard on how we could convert this to an... I should move my window out of the way. I knew this is like a shitty location. I don't know where to put my streaming window, like up there. Think very hard on how we could convert this to an event-driven pub/sub agent framework where run can actually be spread, or like where run or the nodes 3-step process can actually be split into many events. So that's all I'm going to say, and I think we'll see what comes out. Like, obviously, this is LLMs. I have no idea how they work. They're probabilistic, so I never really know what comes out. But you can see how long the stack trace is, how long the thinking trace is going to be, starting to be. And I'm going to zoom in so that it's a little bit more readable for the people in the back. I don't know how to deal with like all these tabs everywhere. I think I can turn this into a main tab, so that would be pretty. Primary sidebar. How do I turn this into an editor? I think I know this was somewhere here. Open as editor. All right, cool. Then we're going to move this over to our main tab. What the heck? All right, there we go. It's annoying that it always closes the thought trace, because that's the actual interesting one. 2 things. They put you into the mind of someone who's very methodical and really fast at matching things. And also has like a lot of experience of what patterns to look for. So in a way, it's like pair programming with a very senior engineer that's very like methodical. If they see an ID 15 here, they'll be able to match it to the ID 15 on the other side. And that takes off a lot of mental burden of doing this pattern matching, which I don't know if like young people have to do it to learn what they're doing. I've certainly done it a lot of times, but I'm too old to actually really care about doing this kind of mental labor. I really wonder if it's like important for learning to do matching numbers or not. Like, I don't know. Like, I'd be curious to see, are we taking away a core of what is actually necessary to get a good understanding of these of computers and software architecture? Or are we, on the contrary, maybe all of this like stupid string pattern matching is like actually a hindrance? My take is that it's probably more of a hindrance but also like depending, like maybe it slows you down, maybe you like feel pride after that. Like I learned programming with on MS-DOS, and I didn't have the internet. We only had like an MS-DOS machine with like not even a hard drive and 640 kilobytes of memory. And so the only thing I had that I figured out on how to program is called debug.com. And in debug.com, it's a disassembler per default. So you open it and it will show you the content of all the memory on the system because there was no memory protection. And then you could like look at these little bytes in memory and it would show you the assembly code for it, right? So you would like look at somewhere and it will like tell you like move AX onto this, which is a register, into this memory address and all these kinds of things. And so I had like a very short 20-page like assembly manual. And the thing is, which because I didn't have the manual for debug.com, I only had the assembly instructions. I never find out that there's an assembly mode for debug.com. So I thought the only way I could possibly enter programs into the machine was to put the numbers in, because you could edit memory, but you could only put in the numbers, and then you would put in the numbers until they showed you the assembly that was like the right one that you wanted. And it's only last year that I found out that if you press like Control-Shift-A or some kind of key combination, it switches to an assembly mode where you can write assembly. I'm curious. Debug.com DOS emulator. Is that something you can find online? Like maybe I'm just like making up some weird memories. I don't know. How can I run this? Where can I run this? Can I run? I'm sure there's like online things, right? Run MS-DOS online in a browser window. Is that something you can do? PCJS machine. Sure. Microsoft Adventure. Oh, because it runs like directly with the program. Can't I just have like DOS? We had a Zenith PC, but we didn't have color graphics. PC monochrome display. Oh, cool. 64 kilobytes of RAM? I don't think so. Or, yeah, I actually don't know much about alt machines. What the fuck? Okay. Man, this is, I think, super ancient. I don't know what this is. I had DOS 4. Does that make sense? Software, applications, demos, other, IBM. It was like Microsoft, wasn't it? Learning MS-DOS 1. IBM Basic. Diagnostics. Languages. Systems. DOS. Microsoft. MS-DOS 401. Oh my god, my childhood is coming back. 640 kilobytes of RAM. Come on, show it to me. Yeah. You don't know how much time I spent into this. Is it going to ask me for floppies? Jesus Christ. So I had 2 floppy drives, right? And I had to put one or the other in. So I guess I can load the disk here. Oh, that is sick. Press enter to continue installing DOS. Insert select diskette into... What am I doing? Why am I doing this instead of streaming? All right, another day. The thought traces allow you to do all this pattern matching. And Linux? I'm not sure what you mean, Chandu. This was MS-DOS. But this is Linux, yeah. I don't know. It's Ubuntu. I'm too old to care. The thinking traces are great because they walk you through the system and allow you to, even though you're not thinking very hard about what to match, they give you a very good sense of how things are built. And so it's totally possible that this thing is going to be wrong. Like they tend to hallucinate more in these thinking traces, and that can have like a pretty drastic impact. So be careful with thinking models. They're usually not that useful in terms of day-to-day coding, but sometimes they are. The problem is also that they, especially Gemini, just like adds a lot of tokens to your conversation. So be aware of that. Like, but so here it will already explain like the key components of a pub subsystem, right? Like we have an event broker, as I said before. It's like something that is going to receive events, queue them, and say like, yo, you get an event, and you get an event, and you get an event. And it's like, oh, you didn't like my event? I'll send it again. Those kinds of things. Events are like data structures that are usually described by a schema, and then you can check which event you received and like what data is in there. And then publishers publish events, right? And then subscribers receive events. And so here it's going to start, these names are actually going to match this stuff over here, right? Like it's not describing an event system in the abstract. It's actually describing an event system in the context of our agent flow. So it's starting to fill in parts of its output tokens with information that's directly relevant to us. And the way I think about it, and all of these prompting techniques like chain of thought and blah, 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 is like what you want to do because of the fact that models through the attention mechanism are going to look at their past history, right? And then so they're going to say, oh, well, for the next token, it looks like I'm going to have to look at these old tokens and these old tokens and these old tokens through the attention key query value thingy. And so what that means is because they're going to look at their own output the same way they're looking at our input, right? Everything they output is going to is best if it helps them output better stuff, right? If you can have them output that helps them output better output, then you're doing good job prompting. And so that's what I think of when I do these thinking models, or like straight from the beginning is at each point I'm like, okay, well, what can I prompt the model to cause it to output more useful stuff? So that as we progress, we get in the context window, literally all the useful stuff we need to come to the solution that we want to. So that seems maybe like a little bit subtle, but I don't think of this as a conversation. I think of this as an iteration over creating a block of tokens that when I give them to an LLM, it will output the final solution. So it's not a conversation where I'll be like, oh no, let's go back and let's talk about this. Let's talk about this. No, everything in here is like geared towards having all the information I need to give the model to have it output the stuff I want. Because there is no conversation, right? There is only text. There's only text in the moment. There's no memory, there's like no tools, there's nothing except text for models. And when I send them a block of text, they're going to answer with another block of text. The fact that we think of it as a conversation, as stuff with memory, as terms of function tools, that's all stuff we layered on top of it, saying that, oh, well, if you output a curly brace in this way with this preliminary token, I'm going to interpret it in this way that I can then do a tool call. Like all of that is made up. The only thing that matters is you send something to an LLM, you do some inference on it, and then you get back more text. And so if you have to pretend to be a conversation, sure, then pretend for it to be a conversation. In fact, they're trained for it to react like a conversation, right? Like that's the whole thing that led to ChatGPT, is the reinforcement learning through human feedback to even teach these models that they're supposed to act like in a conversation manner. And the fact that the API fools you into thinking that a system message is the same is different than a user message is different than a system message. They are different, but in the sense that they've been trained on thinking they're different. But as far as the inference goes, it's just like tokens, and maybe removing some of those tokens will lead to a better result. So all I'm doing in these chats is actually, I think of it more like writing a big file. And in this case, sadly, I can only append to the file or like go back. I can't like edit lines in between, which I really think, say AMCode people, if you're listening, or even Cursor people or whatever, is like, I want to edit what's up front, right? Like if I spend 50 messages getting a file to be right, which I don't do, but if I like after 50 messages I get to like a right result, then I would kind of want to delete all these results and say, hey, LLM, you came up with this straight out, like continue, right? And the LLM doesn't know better for it. Like it doesn't have memory. It doesn't have nothing. It just like thinks that, oh yeah, well, when the user gave me this, I output this. So I seem, right? It's like you save your context window a lot. For example, even if you have like the LM outputs a file and then you start modifying this file, you're actually having like wrong copies, like discarded copies of the same stuff over and over, while you could actually say like, well, you came out with this file right from the get-go. And anyway, I'm getting into the weeds here. But I do think of this as a way of building up to, and we're getting back to our event-driven thing. It's like all of this is me starting from zero understanding of the code base, but already thinking, okay, well, how am I going to convert this to a event-driven thing? And let's do it in this context. So first I get a lot of node that tell me like, oh, well, what is a flow? How are results handled? Maybe a little bit of code here and there. Then I'm like, okay, well, explain what this means. Add some little more words that tells me like, oh, well, there's an action string, and then we do this, and then we do that, and here's some more code. And then I'm continue saying like, okay, well, find the actual code here. And it says like, okay, well, it's in the init file, which is cool. And so now it starts to really dig into the existing code, which might be good or might not be good, right? It's like, if I do want to have an event-driven system, do I really want to have low-level code of something that is not an event-driven system? Because it will start building an event-driven system that matches the low-level code of something that's synchronous. So it might certainly be like very unidiomatic and just very weird. I suspect that models like Gemini Pro and all of that, they're like clever enough to be able to get past that. But GPT-4, I would never do this, right? GPT-4 will like build an event-driven system that emulates whatever code it has seen, because it will just like not be able to surface like the underlying reasoning, whatever the bigger models do these days. So GPT-4, like say like things like DeepSeek or whatever, and we can like experiment with it as we go. They will have trouble going from this to a clean event-driven stuff, right? And I think I can duplicate the chat. This is amazing. So we're gonna we're gonna switch to DeepSeek, and we're gonna have it do the exact same thing we did here. See, and it's annoying that they switch everywhere, but you all see what I mean with the difference here. The difference in thinking. So this is annoying to read because it's just like blocks of text. So the formatting of these things matters a lot, because I can scan them. I can look at like the bolded stuff. I can look at the overall structure of these things. So here, so it finds interesting stuff. Like DeepSeek is pretty amazing for something that's open source. So see how it correlates. This is exactly the questions to ask. And I wonder, maybe DeepSeek in this case is like better than Gemini. I don't know. So it will map the run and orchestration. So here you can see it like immediately maps the Pocket Flow concepts that it has seen, because I asked it to fetch the code in the previous message, right? If I hadn't asked it to fetch the code, there's a chance that the agent tooling would have caused the model to say like, well, maybe I should look at the source code. But it's entirely possible I've said like, sure, I'll go ahead. I've got the documentation and I've got like high concept words. And in this case, it might even be like a good enough context, right? But I wanted to see what happens when I take all this low level stuff and mix it, right? Like remix it through a thinking process into something much more architectural. So we'll see how to continue in a second, because I need to drink. So I'm actually impressed by the DeepSeek thinking trace here, because it's really asking the good top level question. It's not diving into the code stuff. So I wonder if it should have that as a context, right? It's weird because it doesn't mention any symbol that it has seen here before. It's very interesting. Very, very interesting. I don't play with DeepSeek nearly enough. And we can see like this is very decent. But it doesn't have like incoming events that would trigger it, right? Which maybe doesn't even matter. Like maybe this is just like one big thing. Maybe that's good. And then what does DeepSeek do? So DeepSeek does have like this much more detailed thinking trace that matches much more closely what it has seen before, which is really interesting when debugging, for example, or like exploring a code base that maybe is your own, and but also just like code bases you don't know, because it will give you like a very maybe too detailed map of like what matches what. So I had to do like some kind of tricky debugging today. I posted about on X, and that was tremendously useful. I just gave it like a long log trace and our stuff, and it was like able to figure out some pretty cool stuff. So starting a flow would publish a flow start requested or node execute requested. The next node logic get next node needs to be managed. This could be part of a dedicated orchestrator agent. So this starts to get really interesting, right? Like we can see the solution that DeepSeek at the end came up with is nothing. This doesn't help us in the least, right? It just says like, there's like, I mean, it's kind of interesting. Maybe it would be good to have a flow that's that simple. But here it's actually starting to think about the things that I was thinking, which maybe are too enterprisey, but also is like the way event system driven systems are built, right? Which is, well, if we do get a node completed event, which could come from the past, right? Like who decides if this is even the active node? If it's not the active node, then we need to ignore it, which can happen in a distributed system, right? It's like there's some latency between the systems, like maybe a node goes down and then you come back up and you receive like node events from the stuff you started before you crashed, but are not yet in the database. Like stuff like that can happen. So you need to be much more flexible in an event-driven system. The advantage of an event-driven system is if you consider what LLM agents are at their core, right? It's things that call APIs, cool, right? Like a web search API, or like they save files on disk. Okay, great. That's like nothing crazy to think about. They call shell scripts. Okay. So what makes an agent program special? Well, it's like we have this one thing that's called an LLM, and calling an LLM is super expensive. It's super fucking slow. We need to stream the output if we want to have like a nice UI that feels responsive to a user. And this resource of the LLM, it's like strongly rate limited. It's like dog shit in terms of reliability because there's so much demand and these things go down like every day. Like it's, I subscribe to the alerts for OpenAI and Anthropic and I get like 20 a day, which is like you usually would expect if you subscribe to a service provider to get like 1 or 2 a year, maybe, not 20 a day. And anyway, so that what makes LLM systems complicated is like super expensive call, right? Like a call can literally cost you 10 cents or more. With thinking models these days, a call can cost you $8 or something like that. And so if you do agents this like synchronous way, basically per agent, per application, you're going to have a whole Python process. And the only job of the Python process is basically to wait on LLM calls, right? Like while the LLM is doing something, I'm doing nothing. I'm just like waiting. The computer has nothing to do. It's just like waiting for the next byte to come from the LLM, or like in this case, for like the whole response to come. And then maybe I'll be like, oh, does this like contain tick, tick, tick something that I'm going to parse out? Okay, cool. And then you wait again. So your agent does nothing. It literally, the only thing it does is have like a little state machine and maybe like 2 or 3 grep calls or like string replacement things. And the rest of the time it just waits for HTTP, and you'd be like, this is like the most trivial program on earth. Why does it need to run a whole Python interpreter on a whole VM for just waiting on HTTP calls, right? And the next problem with that is like you have this long running process. So maybe if you do a super expensive LLM call, right? say an O3 call for like $5, and then you're like, well, I want to extract the XML, and you have like a bug in your Python expression for the XML, and you crash. Like string index 15 doesn't exist or something really stupid. You lose your $5 of inference. So either you were clever enough to cache it so that you can resume, but this resume logic is actually really, really hard, right? It's like you're going to be like, well, I crashed, so now I have to reload my state and I have to go back here, and I don't know if like the 15 calls I did to my memory layer are going to result in the same result. Like all of this is actually pretty complicated logic to resume like long-running sequential programs. However, in an event-driven system, you're just like, well, it seems like we crashed and we didn't receive the last event. It's still in the event broker. So when I start back up, stuff just continues, right? And the thing is, like, while I asked the LLM to do inference for me, I can process the program that runs, right? Like it's basically just waiting for events, doing something in the event, and then handing it off, and then waiting for the next event. And it can do so very efficiently. Like there's good abstractions to wake processes up when their bytes come in over Ethernet. And I can process like 1 million of those, right? It's like while my 1 million requests are running on OpenAI or whatever, I can handle more. Like that's so trivial, right? To handle an HTTP request, especially your one little computer is actually, its CPU is actually busy doing something at this point. It's busy doing 1 million agents at a time. It's resilient to crashes. You get an event log. That means you can replay a whole thing. Like if someone tells you like, there seems to be a bug with the XML parsing, like the events that led to this bug get put on something that's called a dead letter queue, which allows you to look at them later on and say like, well, it looks like this event didn't work. Let's find out the bug. And then even crazier is that once you find the bug and you put the new code in place, this event will suddenly like work. So like stuff literally can be resumed even though it was crashing before. So there's like all these crazy advantage of doing it in an event-driven way, but also the code looks horrible, right? But the thinking here is that this declarative code that we have in this framework where you do like the node dash action goes to another node, hopefully we can use that exact same syntax to connect our event-driven systems together so that we kind of get the benefits from both worlds. Maybe our nodes are a little bit more complicated to write, but we don't care because we're just assembling them at some point, right? So that's the idea behind all of this, is to make nodes that are going to be a little bit more complex under the hood, but make it so that we can connect them in a very elegant way. And I see already, like I haven't even started writing any code and it's already like 1 hour and 15 minutes in. I need to factor that into my stream planning to maybe keep more of a schedule as we go. So anyway, going back to our Gemini trace, it's going to decompose our node steps into a pub/sub mechanism, right? So a prep step could be triggered by a node prep requested event that comes in, sure. And then we send a node prep completed event, which also, sure, this is DeepSeek found that out here, right? Except here, it's not triggered. It's just like sending out events. So DeepSeek, not good, my friend. So we're going to close DeepSeek, and then one day I'll do a stream where I only program with DeepSeek because it is a really good model for what it is. But we're not here for fun, are we? Oops, what did this scroll? So here it proposes decomposing the 3 steps into like command comes in, response goes out, like a very simple scheme, even in event-driven systems. The thing is like who receives this event and who sends the next one, right? So in this case, it says like, well, it's sending it to itself, which I don't know if this is like such a useful idea here. I think it's more, actually, yeah, no, that's a good idea. Is it? Who knows? We have a shared store. So this is tricky, right? Because it's like a mutable dictionary at the moment. Like, do you want all your things to write to the same database? Because suddenly you have contention, right? Like if you have 1 million workers, as I was saying before, if you have like a thing that handles like 1 million workers, you can easily split it out onto 10 machines, right? You can say like, well, since each event is its own little thing, I can have 10 10 machines, like handling them, and now I can do like 10 millions. But the problem is if these 10 million things suddenly just hit the same database, suddenly you have contention on the database. And that can be pretty bad because suddenly like maybe one node that is slow is holding like a lock on the database to update a state. Suddenly all the 10 other nodes are slow, right? Because they have to wait on that one transaction lock. So you can easily have something that scales really well, and then you put like a shared database and everything just crawls back to potentially even slower than a single node. So shared stores, usually when you have microservices, then each node is going to have its own little store, and then it's going to serialize that state out so that kind of every event has a complete state that might be necessary to handle it. There's like different patterns to do that, right? Yeah, so immutable data and events is the one that I described here. And then you have these like other services that you can say like, well, please store my state for me and tell me when I'm done. And that allows this node to say like, well, let's move on to the other things. And hopefully the data service has a good way of managing that scale that is better than like just putting a SQL database in the middle, right? So it can also manage like priorities, can say, oh, maybe there's a rate limit, so please do like wait later. And that's something we can bubble down to the user. We can say like, we're overloaded, like please try again later, that kind of stuff. And then we do have the successors, which is basically the graph of like what node goes to what. Here, if you like, this is the stuff that I was talking about. Resilience is like being able to requeue. Scalabilities, we can do like many. This is depending on who you are, it's a pro or a con. Yeah, so there's a bunch of benefits, and then of course there's drawbacks. Like with everything, it's like it's complex, right? You have to manage the schema of events. Like what happens if you roll out a new software version that has like a different field in it, but you still have all the old events running in the system, because you're not going to like shut the whole system down. You're just going to be like, oh, well, a new node comes up, and then suddenly it's running a new version of the software which have different events. Event ordering is a problem. Even having like each event only delivered once is a problem, right? There's a lot of things that can be that need to be handled. You have like shared state. Well, I mean, this is the case in the normal one as well. You have to handle the fact that if you can crash in the middle of something, like, right? Like imagine I want to wire you money and I send out money and I crash before you received it. Then what? I need to reverse my side of the transaction, but in a microservice thing, that's like complicated, because as far as I'm concerned, I sent out like money transferred. I'm good. Like my job is done, but actually I'm not. So there's like, this is pretty complicated to build. You have to do this thing like competing transaction. There's a lot of patterns around that. Tracing can be easier or harder. Like that depends on who the person is. I find it easier often to trace a flow because I can filter based on a transaction ID. And then I just need one big event log to look at. If I had many, and I can do queries like, show me all the failed HTTP events across this fleet, which is harder in some ways to do when you have like many long running things that might not even log if there's, I don't know. I'm getting into the weeds. Maybe I'm not right on this one. And then, yeah, of course, it's going to be slower if you always have like network transactions in between. So let's look at the event-driven flow that it proposes. Like you have a flow execution. This is the run method. Then we have the like node activation requested. Then we have these like 3 node operations, and then we have these 2 top level ones. So like nothing is too crazy here. It's just like, well, you start a node, and then when the node has finished its post state, the flow engine is going to receive that and then potentially activate another node. So that seems like a decent, good start that we could have, right? To start converting this to an event-driven system, where if we then look at what comes out here, this is usually pretty close to what the thinking process is, but not always. So you can see that it's flow execution requested is what it comes out here. And I've seen this very much is that the symbols change once they get into the normal output, and they change subtly. And I don't know what that is. But I've seen this over and over again where it has like makes up variable names here and then they get changed over there. And it's kind of tricky when you reason about real symbols and then in between it starts to modify them. And then you come back with something that doesn't correspond to the symbol that it actually should be. And then it destroys. So thinking models are to be used in moderation, or like know what they do, right? Or like having your feelers out for this kind of behavior. That like, why did it decide to go from flow execution request to flow start request? Is like, I actually don't know. I don't know why it does that. Like what the behavior is behind that, the reason. So, but I've seen it over and over with Gemini. So it does things like if you have something in camel case and then it puts it into snake case and then it like puts it back out to camel case, but suddenly it's like reversed. Like that stuff happens quite a bit. And obviously it's like tragic for the code that comes out. So we do have subscribers and publishers, state management. We're going to keep like this shared database maybe. Flow initialization, we have a flow start requested, which is going to the flow orchestrator agent. I do like that. So this is the replacement of our flow method, which we can look at here. This is cryptic code because it decides to be cryptic. But if we go to flow, it's called literally orchestrator as well. And then, yeah, this is cryptic code. And so what you can say, like, explain this in normal human words. And then if you press Alt Enter, you can ask a question. So it won't modify any code. But then, see, this is the loop in here. And I don't know why they want to be that cryptic. It's like they want to say, like, it's 100 lines and not like 200 because I'm indenting like a pig. I think that's why this is all like so golfed. It's annoying to me a little bit. Like I don't care about this one, but it's like hard to read. It like doesn't match my patterns, visual patterns. I can't imagine that this is, I mean, not that you would want to use NetLM to edit something that's 100 lines anyway, but I don't think NetLM would just like not put up with this. The training corpus would be too strong to modify this. Maybe not. Who knows? So it uses the output of one node to look at, right, like we have the last action is here, and then it looks at the get next node for this last action, and then get next node just looks at its graph that it has stored and sees, is there for this node and the successor something that's filed under that association? That's the thing that this little bigger symbol does in the Pocket Flow. Copies nodes to prevent state sharing. Sure, that's interesting. And then passes parameters and shared data through the node. The copy is interesting. It's so that it does make sure that each node instance is its own fresh one. I don't know how copy works in Python. Or deep copy? Is it a deep copy? Like how far does it copy? Oh, no. And I pressed the wrong key, right? Like this, I should press Alt Enter. And I think you can't do it, add a follow-up. Anyway, we lost our first conversation. That's my fault. Okay, so it references the same nested object, right? So it's a shallow copy, which is tricky. So I'm not sure what this is for. The copying the nodes, is that necessary? Maybe. I don't know. Maybe it's just something I can't figure out while talking at the same time. Anyway, going back to our event-driven system, that's what the orchestrator does. And so the orchestrator would keep the same data structure literally that we had. It's going to say like for this, when this type of node completes, then, and if it returns this string in its node step completed event, then I should send a start node thingy with this node type, right? Like we have node types like node class, and then we have the string that's the dispatching action. So we need to keep a list of source node, arrow name, like edge type, which is a string, source node type is a class name, and then a result class name. And we're just going to say like when this type of node emits this type of event, we are going to send a node start event to this class of node. And in an event-driven system, that would be, instead of node classes, we could call them topics, for example, is like one thing we could do, which is there's a topic for chat. Every message that gets to chat node is going to execute the code that is stored in the chat class. And then every incoming message that has been, every node step completed, published to the chat topic is going to be parsed in the context of all the arrows that go out of this chat topic, if that makes sense, right? So I wonder if it came up with like using topics for classes. I'm not sure. Centralized store, orchestration logic, atomicity, the 3-step process for long is no longer a method call. So we have to ensure that. Error handling and retries, item potency, all events. So this is because an event can be delivered multiple times, right? So we'll have to deal with that. And so it doesn't talk about topics. So we could ask it like, what topics and would I use, and how would consumer groups be split? So consumer groups is when you're within a consumer group, it means that you can subscribe multiple services can subscribe to the same consumer group. And that means within this consumer group, the events are going to be dispatched to any of the nodes. But if you have a second consumer group, the same events are going to be all sent to that other consumer group as well. So you can have like, you don't steal events from each other is what I'm getting at. You could have something that listens to a whole topic and just uses it to display things on the screen. But at the same time, listeners that actually do work can be in their own consumer group and be like, yeah, when we consume an event, we're actually going to do something else with it. So I don't even know if that makes sense in this context here, but we're just going to, it's just like little keywords to put in that will trigger the thinking mode of Gemini. And so we can start looking at it. Specifically, Kafka topics, what specified topics would be used, consumer groups. So here again, you can follow this and get some pretty good like idea of how a senior software engineer thinks about this in a very rigorous manner. It doesn't mean that they're right, but it's rigorous. And just rigorously looking at like your code structure and the topic can be really good, even if it's wrong. So here it starts designing payloads, which is pretty nice. That would have been my next question. You can see very interesting things. So, oh shit. Oh no, it's finished thinking. That's what it is. So you can see there's a flow definition ID. So that would be the name of what type of flow I do, which would be in thinking back to the Python would be an instance of the flow class, right? You could say like, or actually a class that inherits from flow. So you could have, say, like a research flow. And then you would put in here flow definition ID research flow, and then some initial data. And the flow instance is going to say like, okay, for the whole run of this research agent, use the ID 15, for example, right? Like we have research number 15. In the Python world, that would be your Python interpreter. You could say like, I started my Python interpreter. It's going to do one research agent run, and then it's going to exit, and it's going to have like the process ID 15 or whatever. But really the unit is the Python process. Here we don't have this unit, so we have to stamp all these events in a way that says like those guys are related to each other. They're part of the same research, started by one user at one point in time. And so that's why this flow instance ID is going to be in every payload, right? Because we need to correlate them. And so I don't know what flow continuation requestion is. Node prep instruction created. So this is when hallucinations start to get weird. Like, what is node prep instruction created and continuation instruction? Like, why did it decided to rename it? Because this is a weird name, isn't it? I don't think it matches anything in here. Because like obviously orchestrator matches this, and then started is obviously started and post or like run are all in here. I don't think there's something that's called continuation in here, is there? No. So I wonder where this is the new version of Gemini. It seems really strong at doing this kind of nonsense, which I don't remember seeing the previous version do as often. So we don't know. I don't know exactly what this is, but it looks like this is just a signaling, like it just like for logging purposes. And then this orchestrator is going to send node prep requested with the flow instance ID, and then the node type. I'm not sure what the node ID is for. I would probably call this more like node execution ID to say like it's one call of a node, but maybe I think that's what it is here. And then the node type is the node class, right? So you can say that would be the topic maybe. For each node type, I think you should have a topic, and then you can delete this from the node, from the content, but it also doesn't hurt to have it in the event payload. And then you have all these like data things that come in, and the shared data is going to be an interesting thing if we do want to make this distributed. I would imagine that you could, not worry too much about like contention on the database just yet until you get like gazzy millions of users. But and then you can still shard very easily by user ID. So we're going to assume that our shared state is basically to start with just like a SQLite database or something like that, maybe. Or literally each is going to get a repository. It could be like a shared hash map behind it. I don't know. And in these events, when it has finished the completed prep, right? Like we could say, oh, does this go back to the orchestrator? Maybe. Or does it just like immediately trigger this one? And so the nice thing now is like, imagine we have a node that does an LLM call and does so through an LLM service that's separate, right? And the LLM service is pretty nice because it's the one thing that owns the one provider API, the really expensive API of LLM, of OpenAI, say, for example. And having that, a whole service only do HTTP calls to OpenAI, it allows you to do pretty easy control of batching, pretty easy control of like priority queues, pretty easy control of rate limiting, because the code for it is just going to be in one location, right? If you have 200 Python processes that have to kind of coordinate their rate limit impacts, or saying like, oh, well, this Python process is more important than this other one because this is a free user and this is like a paying user, synchronizing that across many, many Python processes is a bitch. And with event-driven, you can put it all into one process and say like, well, I received 30 events from the high priority users. Maybe I should let like 2 free users go through. You can literally write that in there. So it's kind of exactly the opposite, where normal code is kind of hard to write in an event-driven system, but like complicated code is actually very easy to write because it's actually closer to what the world looks like, right? So anyway, Kafka topic strategy, 1 topic per major stage, partitioned by flow instance ID or node ID. I don't think that's very good. More granular topics. Yeah, I don't think any of those is good. I think 1 topic per node type is the better way to go. I think that is much more interesting. Yeah, and so this is where you can't like trust models, right? Like they might do something, and maybe they're right in this case, but they can also, in assembling their words, just like miss what is actually the really good idea, which is potentially, and I'm not sure if that is right, to do 1 topic per node type. Because I think that's the one thing that makes the most sense to me is this doesn't make sense. This is just like, it means that all the node types are going to all the time send stuff on the same topic, and there's no reason why they really should matter. So I don't think this is good. But we went through the whole story here and like kind of analyzed it. So now that I have my answer, right? It's like the context window did its purpose, which was to generate this stuff, and then I realized like, yeah, this is kind of garbage. I got the information that I needed. Maybe some of the information is something I want to keep. I don't think there's too much I want to keep here, but you could imagine that you have a UI and you say like, well, please delete these 15 lines, and then basically editing your context history, which like certain UIs allow you to do. And in the very early days, I was using Emacs, and you basically had org mode open, and you could say like, please LLM do an inference on my selection. And the LLM inference would come out in the same org mode file, and you could edit it. And then you could like basically, select chunks of your file and say like, well, please do an inference on that, and then edit the result and like reorder it. And so that was really, really cool. And it's like kind of something that I really miss in today's IDEs. Like you have this little thing here, which is nice, right? Like, but can you do multi-select? Maybe you can do multi-select these days. And that's maybe like the closest that this comes to, but it's like not like it will filter out code for you, right? Like I can't just like drop the chat in there. So it's a little bit limited. It comes close in terms of the idea of it, but it's not the same. So going back to this, I'm like, okay, well, this like all served its purpose. I don't need it anymore. Let me just like chip it off. So usually I'll go back, even though this is useful, I'll just be going back and just like editing it. And if I find it useful and I want to reuse it in the future, the stuff that I do, for example, now that I know this, is like model the system. Each node type is a topic. So if you want to start the inference of, I think this is enough actually. Each node type is a topic. There is a global agent run ID, and then there is a node, actually flow execution ID was a pretty good one. Flow execution ID for a whole run. There's a node execution ID for each processing step. No, for each node run, I think is what it's called. And then I think that's enough. Design a event-driven system. So event types, topics. Well, I guess event types, service pseudocode, example service pseudocode, orchestrator, flow orchestrator, individual nodes. So hopefully we'll get like one of the examples that I'm interested in. And then example service pseudocode, and then plant UML. Oh, actually, can Mermaid do timing diagrams? Mermaid time diagram. Can it do that? I'm like a plant UML dude. Timeline diagram. Yeah, no, that's not what I want. Sequence diagram is what it's called. Oh shit, they added like a ton of diagrams. That's crazy. All right, well, plant UML, I guess, is dead, huh? So this is something that I will want to edit, reuse, do a lot of stuff with, because I can't do it in the chat itself, right? Like the chat is not a document as in my opinion, should be. A chat should be an editable file, and maybe you have like an easy way to append to it in a chat kind of interface, because, I'm not going to lie, sometimes I think I am chatting with a model, but having it be like a file that you can append an LLM inference to, I think would be amazing in terms of like a mainstream IDE. But for lack of a better world, we'll just like put this into a file. So I always put them in like named files, and it's like first draft, and then I'll give them very explicit names for two reasons. Is like, A, it saves me on prompt engineering. If I ask it to create a file that's called like how to eat an egg, it will actually create a file that explains how to eat an egg. Like I won't have to say like, write a file how to eat an egg that explains how to eat an egg. So it's just like a quick way of doing that. But also when you do an ls or a find on the repo, which these tools do pretty often, it will immediately know what the file's for. It won't be called like plan.md. It will be like, oh, this is how to actually go hunt for, rabbits in the forest, instead of plan.md. And then you have to look at plan.md, and then it says like plan for hunting rabbits in the forest. 2 tool calls, which adds up really quickly, right? So first draft, output into ttemp, first draft of an event-driven Go version of Pocketflow. So this is the first time I introduced the word Go, just because I am, now is the time. There, that's it. Assumptions for this model: generic message broker, that's cool. State store, used for managing state shared data, sure, why not? If I don't like it, right, there's a possibility that I'll either like the document, and then I can still go back to this message, just link the document at this point, right? Which would kind of be a way of editing the context window up to there, except I can't, so I'm just going to save that into a file and then link it. Or I might just do a whole new, if I see that there's nothing that can be like quickly salvaged, I'll just like regenerate with a better prompt. But so in my head, it's really about editing this context window, and I'm trying to bolt that on to this UI that I have, which is what I want is like edit this big string that I'm going to pay for when I send it to the LLM. And what agents and UIs give me is just like an easier way of building this up, and potentially like building it up from my very first line, and then it just like automatically does the whole stuff. Totally possible. But when I do my chats and I do my files and I link files and I, edit files and then go back in history and link them again, that's what I'm doing in my head, is actually adding a big file, the context window, which is what I'm going to be paying for when I send it to the LLM. So I'm still also like always conscious of like how many tokens I have in there, especially with many more tools moving to token pricing. If you use the API, you're paying per token, right? Like that's what matters. So even if you have like a million lines of documents, and then here Gemini did the thing. What I suspect is we're at like 60K. Oh no, we're at 40K. What did it do? I suspect the resulting document was way too long, including with the thinking trace, and it cut the tool call short in the middle. That's my suspicion. I have no idea, because when I switch to the Max model, it usually works pretty well. We're just going to go with Sonnet, which at least is like able to write files better, it seems. Because at this point, I don't need like a model to do all this like yippee kind of mixing together. I think there's enough in there to not have to require to this, but we will see. So it's wasting a tool call, creating a directory that the edit tool could do. Like, I hate that. Because here, what it's happening, right? Like, I don't know how the new Claude streaming tool call work, but if you were to do traditional tool calls, you would take this huge files that I built and then basically pay for it twice just to create a directory. And it's like, why? Right? It's like, just make an edit file tool and tell it to like, this edit file tool is going to create a directory if it needs to. Because why did I have this whole huge window just to do the generation of JSON that tells me to make dir, which I literally only would have needed like 20 token to explain you how to do, right? Like, I would need literally just this prompt in here says like, create this file called by this name to get back the response. I don't need to send much more. I don't need like all of this stuff to create a directory, right? But I did pay for like 40,000 tokens to have it generate this, and then now I'm generating something that is worth sending 40,000 tokens for, right? So anyway, this is like my long-winded way of explaining how I think about LLMs, and I think seeing how, I don't want to toot my own horn, but seeing how more often I am successful getting something out of an LLM, I think that might explain partly why, is that I think much more closely to the model than UIs and training modalities even are trying to make us think we should be. So yeah, I don't know. I also think they're just a pile of floats and they'll never gain consciousness or whatever. For the record, they'll never be like intelligent. They're freaking like probabilistic compute engines. And that's why I like toying with them, right? Like, some people are saying like, please, and make complete sentences and do like, try to not make grammar errors and like typing errors and whatever. I'm like, who cares? So that's why my prompting is like often a little bit brutalist. But then also I'm like prone to anthropomorphizing these things as well, right? I'll be like, put a like, so the dashes do kind of make sense. The fact that I uppercase design in this case, it can make sense, right? Because it says like, well, this is 1 unit, this is 1 unit. So it's very close to like human language, but also actually looking at this, like the fact that I put all of these words are actually like pretty good minimalistic thing. I don't think I don't think there's much that I can remove here. Like I could remove there is a, I think. Now that the file is created, by the way, we can start experimenting, right? So I can do like, if I remove this, each node type is a topic. I don't think I can remove much there. Like I do need this. I think that the colon here is important as well, because it says like model the system and then comes the system description. If I remove this, I think that is not as clear and might have some pretty drastic implication if it doesn't understand that I'm describing the system. So I know that this is going to be enough for these models to kind of do the separation. The dashes are important because they give this like a logical grouping, that these are 3 things that are related to this there. And then when I change the formatting again with an uppercase D for emphasis, like I think I could get by with this because there is enough. There's an empty line that doesn't have a dash in the front. And then model the system. I think the word model is not the great one, right? Like I think I could actually do this. Actually, this is probably something where I could save a few tokens. Not that this matters that much these days, but also saving tokens is like, it's just like a much more controllable way to prompt because you only have like 8 parameters, right? Why is this editing select so weird? Design an event-driven system. I'm so tempted to put like the dash here. I don't know why. I don't know why. And then output is like what I want as output, right? And then I think I can probably just do this. Of course, I'm not going to golf everything here. Like tokens are pretty cheap these days. And so whatever comes into my head that is like roughly in the right direction is probably good. And then when I get tired, I actually start chatting too much as if I were chatting to a real person instead of like being an engineering mind. But so this is, I think, I don't know how many tokens we saved, like probably 20 or so. This is, I think, as minimal as it can get. I don't think I can remove into. I think I can do this. Yeah, because it's write, one word, file name, then colon. Colon makes sense. I think I could get rid of the colon. But somehow my gut tells me, no, don't do it. It just feels weird as a human. And if it feels weird for a human, there's a good chance it feels weird for an LLM because they're being trained on what feels good for us. I don't think I can remove much here. Event types might even be like a bad word. I think diagram I can remove because mermaid is, I think, strongly reinforced by the fact, but diagram is just too much of a semantic thing that like mermaid timeline for us as developers kind of means something, but mermaid timeline diagram is like so much stronger. And then example service pseudocode, example nodes. I think here I should put in like, I don't know. But what we're going to do now, since we already created this once, right? We're just going to call it 02. And when it asks us, like, do you want to revert your thing? We're going to say continue without reverting. So now we kind of like branch off our discussion, right? There is now branching off in the UI, but I'm just so used to this behavior. And I would have to edit the file name anyway, so. But this means like our previous inference, right? Like, as said, I think of it as like, I'm going to send you a lot of tokens. I'm going to pay for these tokens. So I want a result that's like worth what I'm going to be paying for. And the thing that was worth paying these 40,000 tokens before is now saved in this file. So it's not lost, right? And so now I have I kind of have my value saved in my bank, like in my sock, right? It's like I'm not going to lose it, and so I can regenerate. I can go back in time and maybe try, and I already have this like result from the future of this conversation, right? Like that's really weird. Is if you think of this as a conversation, but I can go back and edit here, and I can actually give it stuff that it came from like further in time down the conversation. If you like thinking in chats, and you can literally tell the model, this is you from the future telling me this, and that will have a meaning in that conversation that often is quite interesting. So this is a prompting trick that I haven't used in a while because the model got so good, but like with GPT-4, that was a really useful way of putting tokens into relation that wouldn't be immediately apparent or would need quite a few words to describe. And here I could say like, you from the future says that you shouldn't do it. Like, what do you think? And that would like maintain a lot of cohesion in how it was relating to things. So the models now are too good to kind of even be like reacting to that kind of trickery. But I'm sure that's going to be interesting for DeepSeek, for example. Because if you tell like a reasoning model, this is you from the future, it's going to do a very different kind of reasoning than if I don't tell it that. If I just say like, oh, here's a better version, right? Because it's going to be able to put its own past output, which it knows because of these like assistant tokens, into relation with the stuff that was corrected, and it's going to be able to say like, well, it seems that I think that I didn't do this. Like it's even going to use the word I like twice, which is really weird and important. So anyway, I don't know if that makes sense, but these like weird prompting techniques of like, you're an agent from the future. I don't know if I can show that actually. Can I show that in the current context chat? Yeah, actually I'm going to use it. So I'm going to say, just because, so we created this, and then I'm going to do TLDR quick rundown of the finished design. So I'm going to take like the finished design, right? I'm going to try to make it very short so we can kind of see the impact of it. And no, this is kind of like not what I wanted. Whatever. We're going to take that, right? And we're going to say, we're going to go back in time. We're going to split the conversation. So where's the first event-driven stuff we brought up? It's here, right? And then it yapped a lot of stuff, which wasn't all that good. No, this was decent. It was like when I started asking it about the topics, right? Which we already deleted. Shit. But let me go back here and let me duplicate the chat at this point. So now I'm in the past, right? And then, oh, this is not where I wanted to duplicate it. Hold on. I want to duplicate it after all of this. And I'm going to duplicate it, and then I'm going to switch to DeepSeek just to use something that's probably going to be more reactive to my shenanigans. And then I say like design the topics and services in pseudocode. We're going to see, I hope that it outputs something wrong. That would be cool. If it outputs something right, that's weird. Also realize that the previous block here, that was a conversation with Gemini, right? Like if we think of it in conversation, I basically just like switched the entire personality, which is maybe like a weird way to think about it. If you just think of it as like, oh, well, I'm using a certain model to do an inference on this string to get this new string, and then I'm going to append this new string to the first string, and I'm going to send this again. Then it's much easier to think of like, well, when do you want to use this model and when do you want to use this model? It's like, well, it's based on whatever value I want to get out of this inference, right? And I don't care about switching back and forth, because for me, it's like, oh, a reasoning model is going to do this certain type of work, but it's maybe going to be worth it writing. But later on, maybe I want to be good at writing, so I'll switch the model back. Or certain models have like a bigger context window, but they're like more expensive to use right from the get-go when you pay with this like weird cursor model, which is why token-based pricing is like interesting, right? Like then the only thing that matters is the length of the string that I send in. It's like not, you don't have to like gamify your requests. And the company doesn't have to gamify the request on the other side either. They can just like concentrate, okay, we need tokens and we produce tokens. So the thinking here is like, it's very high level, the DeepSeek thinking. Isn't that weird? I'm going to say design the topics in pseudocode, refer back to all the real names as much as possible while thinking. I haven't done much prompt engineering or thinking models, so I'm not sure what's going to happen. I'm not going to revert because I'm afraid that it will delete these files. So wait, it's doing DeepSeek. DeepSeek is doing agent. It's doing tool calls now. That's wild. So let's look at the trace here. Looking at the existing code, the flows class org method is the main loop. In the event model, this loop is requested by, yeah, this is pretty nice. Like I'm impressed for an open source model. This is completely crazy. You would have shown me that last year and I'd be like, get the fuck out of here. Like there's no way that GPT-4 would be doing stuff that's that useful. And oh, I'm using that word useful again, right? It's like the inference is useful. It can be wrong, but it can still be useful. It just means that I maybe have to pay a few more tokens to make it perfect, but it is, I'm thinking in terms of like, is the output something that is worth what I put in? And can I reuse it? Does it have value? Some of the outputs have literally no value, but broken code, like I like saying like LLM code is kind of always good. Just sometimes it doesn't make sense or it has no value, right? Like hallucinated code, it still looks like good code. It's like maybe consistent, maybe it has like the right algorithm in it, but it doesn't work with my other code and it's too much work to make it work with my other code, thus it's useless. But maybe it's the wrong code, maybe it has the wrong variable names, but I know that in like 2 keyboard shortcuts, I can fix the variable name. So really useful, right? But I'm not going to do the fixing of the 2 variable names by a follow-up because that's paying a lot of money for something I can do with 2 keyboard clicks, right? On the other hand, if I know it's going to take me a lot of time to clean up a certain file just because like the comments or just because like the packages are wrong and like my IDE doesn't support like drag and dropping files across namespaces, like all kinds of stuff that's completely trivial, right? It's like it put like a wrong namespace, but too bad my IDE doesn't allow me to fix it quickly and it would take me 10 minutes to fix it. Then it's worth me paying like 20 cents or whatever to have a model clean it up for me. Or maybe I have 2 minutes and then I'm just going to spend like 2 minutes cutting down the context. So I pay like only 10 cents instead of like $3, right? But maybe I pay $3 and be like, oh, 3 here, like whatever, do. So it's, if you start thinking of it in like, what's the value of what I'm paying for? Like if I give it this string, and it took me that much time to create this string, right? Like the more time I put into it to craft the perfect prompt, then the more I save in time, and time being like money or whatever you want to call it, it's often useful to pay an LLM to put that string together, which is what agents are for in coding, right? Like the context gathering agents, and maybe they run the script for you and put it back. So for me, that's why all these IDEs and agents, they're like kind of like copy paste optimizers, right? In the code with DaVinci days or ChatGPT days, what you had to do as a programmer before tool calls were becoming like something that was well known, and I would literally just like copy paste stuff all the time. And I'm starting to do this again because O3 is like so much cheaper in the web browser. So I am willing to spend like 15 seconds copy pasting stuff everywhere. But I don't know if that explains, like, I think it's a very different way of thinking about this than like thinking it's a real chat. To me, it's just like a shitty file editor in some ways. And I'm creating these files and it's like some things are nice. And then sometimes it's nice to just think of being in a chat, but really they're like building up these like big files that then when you send them to an LLM, out comes the thing you want. Does that make sense? So I hope it makes sense. And we can look at this, right? And it's going to be like, oh, the flow lifecycle. I don't know. This makes no sense. The flow topics. No, it does make sense. But these are not the names that we want, right? And then we can see here there is wait, where's our write-up? Where's the write-up that we took here? Topic, each node. So now let's look at the thinking trace. If I say this, this is you from the future. Oh man, it's been so long since I did this one. Continue. This is you from the future coming back with hard-earned lessons for you. Heed your future self advice. I don't know. Let's time to have fun. My dear fellow 20-year-old self, here's what I come to believe. Right? And then you can say that. And I don't know, man, it's been so long since I did this weird stuff. And it was a really good engineering technique. Yeah, it didn't latch onto it, right? Like it's been too trained for it. I tried to steer it a little bit with these like weird words. With these like, oh, I'm you. Heed your future advice. So maybe heed wasn't like the best word, and think really hard about it. But I think these things have been like so trained on like synthetic and like boring data now that this stuff doesn't work all that well anymore. But it like in the old models, like the chaos model days, that stuff was like amazing. The future self mentioned, like I saw it a little bit, but it's like nearly not as fun as I said. And obviously in this case, it doesn't really make sense, but I hope that there's like a little bit more of that verbiage in there. What was that? The future self mentioned topics like flow start, no prep completed. Did it? No, it didn't. So yeah, so this is DeepSeek being confused by, I think, itself. It's not good at separating what is instruction versus what is not instructions. So I'm not sure. This is as said, I haven't played with DeepSeek at all. Can we just please stop and try again? Why is it still reading files here? All right, let's try again. Reading files again. It doesn't talk about itself, does it? So I wonder if that's actually the training on the thinking tokens being like mostly synthetic. They're really not like going to do the funky stuff. So let's use like GPT-4o. So like a non-thinking model, which hasn't been trained on these like weird ass thinking things. Yeah. So immediately you could see that it does that, right? So I suspect that's actually something. As said, I haven't played much with reasoning models. Let's see what Claude Sonnet. Yeah, do we have other thinking models? We have O4 Mini, 1x requests. We have Sonnet. We're going to try them all out. So I guess not much ANCode after all. Not much coding. I really, but I think this is much more important than us like getting to the code per se. And also we might have the code already. Like maybe the content of this file is like kind of good enough to one-shot the system. I have hopes that this document is actually the finished product in a way. So is it going to do more about the future self? I'm being asked to think deeply about the event. The message frame is advice for my future self. I should analyze these expense and work. And yeah, I don't know how useful that is, but before it would be able to like basically put these two things that it already knows, the context window, in relation to something that has been corrected, yet still salvage like pieces of it. So I don't have concrete examples of what that was useful for. It's been so long, but it was like a pretty useful technique for, you generate something that's like mildly wrong, you spend a lot of time debugging it, but you don't want to like recopy paste everything in there. It's been a while. I can't come up with like a killer example here. So, however, it did like miss the fact that these should be node types. So maybe it's just like not clear. Let's edit this actually. This is, here's what I've come to believe, and let's edit all of this out. Topics should be closely related to the node type. A like research node would have, yeah, I don't even need that. This knowledge was hard-earned versus the general consensus of runtime flow steps being topics. That was the word, those were the words of fools. Why am I correcting the grammar? I just want to make it funny. Yeah, right. So this is the thing. It's like challenging the approach I just had. And it's like, okay, the approach is not entirely wrong. Like it just was able to just like be better at the code it generated. It's hard to see with these good models because they just output such good stuff all the time. With like smaller models, like easily visible that I just like completely ignored a certain aspect of what you want. And then adding these magic words suddenly makes them reliably produce these tokens. And you were like, okay, well, that's cool. With these new models, it's really like with these big models, it's really hard to see. And maybe DeepSeek v3 actually would be interesting here, right? Because I don't think we have all that many small models. I should add some open router ones in there. But let me rethink this with your wisdom in mind. So obviously here it's like not all that important, but it will keep like all the rest of the reasoning and like kind of give it maybe a more efficient way of communicating that than saying like, look, you should, I mean, in this case, you could just say like, you know, use event types as topics, but as a way to keeping parts of the previous context as relevant and smaller models, now it's kind of coming back. Like the smaller models in the day, if you told them like, no, make the event types a topic, then it would just like discard everything it did before and just like make event type topics without salvaging any of the rest. That was very, very obvious in the smaller models. It's here the big models are going to remember all of that stuff, right? But so I think this is exactly kind of what we want. I don't think we need like 80,000 topics here necessarily. We could potentially dispatch on the event type. So I mean, dispatch on event type in the payload or by topics. And here I actually want like something that I trust a little bit more than, not that I don't trust DeepSeek, but I just haven't used it long enough. What the fuck? Well, sometimes stuff leaks, which is interesting. What the heck? Is this tokens that it outputs? Is this still DeepSeek? No, this is Gemini, right? That is so weird. This is like stuff that this was this like file tool that it was trying to do all the time, right? It's like this. That is weird. That's a weird, like when the behavior leaks underneath. It's pretty funny. Yeah, so you can see it like has a lot of tokens now in its context window. And even though I asked like a pretty generic question, it's doing all this crazy, crazy thinking, blah, 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 blah. And it's, I think something in the DeepSeek output just like fucks this up for Gemini. That was like such a weird output. Is it going to do it again? Yeah. Because I think there's like this code-based context thing around it here. And then there's like a very weird way we'll just like continue repeating the same stuff. This is fascinating. I don't know what this is, what causes it to do that, to just regurgitate files it has seen before. So anyway, fascinating machines. And when you start like experimenting a little bit more in these weird like ways, you can like maybe get more out of them by shifting your way of thinking about what a chat in Cursor is. Like if you think it's like a big file, maybe that's that like is an interesting way of conceptualizing it. So let's actually get some code done before we're done. Let's go look at our and use AmpCode because so we're gonna look at this, and I think state management, service pseudocode. We have the flow orchestrator, and then this is a lot of pseudocode. Handle node prep node service is not good, so this is not a good document. And I don't remember where I called it. So what is the new document? This is 02, right? Flow start, flow completed, node prep, blah, 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 node type, node transition requested from node type to node type. I don't know what the node ID is supposed to be. State store interface, that's cool. Flow orchestrator and whatever. And then summarize. Okay, so this document is good. This has actually something that's not node service, which I don't want. And it's also like very, very nondescript as a name. I have summarize node worker, summarize node, and then the node plus node type prep requested, exec failed. That's great. The router subscribes to all the node events, and this is pretty nice. And then we have like this mermaid diagram at the bottom, which I hope is going to be okay. So you as a user start a flow. It creates a flow execution ID, right? That I mentioned. It then says like, please question node, please execute this. So this message at this point always has the flow execution ID and always has the node execution ID, right? It does the prep completed, which then it listens to itself and does the node exec requested. One of the reasons to do that, this like weird kind of self-calling, is to basically not hog the CPU for too long. Right? To have like many requests progressing, even though you take like 5 minutes to do stuff. It's like kind of a cheap scheduler kind of thing. And the scheduling is like left to the event queue. So it can be clever, it can be like not clever. And then once the node post is completed with an action, then this retrieves the flow definition. I guess this can like be stored in the server itself. So this is a questionable edge that we might want to remove, because everything that looks at this document is going to look at this edge and say like, yeah, let's do that. So so that's a thing to keep in mind. And then we have the next node execution ID, right, which is different from this one. So each node is going to have its own execution ID, which, so if there's like 15 answer steps running at the same time, you differentiate between them. You can have all of them handled by the same program. It will just look up something different in a database, right? So this is a great document to actually give to AmpCode, I think. I think this is like the perfect kind of not too much, not too many. There's slop at the end, which we're going to remove actually. Slop is always dangerous because it will tell or it's not interesting. Like, why do you care about saying that it's great? But these things are more or less useful. So those are really worth looking at closely, because this is going to be an instruction. This is fucking complicated to build, right? And I don't care right now. I don't even have anything. So, and once I get big enough, I'll certainly think about security. Like, I don't want to care about async node, nested flows, or whatever right now. I don't want monitoring or tracing. Like all of these things, if it thinks it has to do them, it will just like make it generate a lot of stuff that's not going to work, that is too much and not of value for me right now. And so that's why I removed them from this file, right? Because I still think of this is the same as the conversation over here. This is just strings that are going to be passed to the LLM. It's not a file per se, right? It's a string. And I'm saving it on disk because I might want to reuse it in the future, but also because the chat doesn't allow me to work with this the way I want to work with it. So dead letter queues for failed messages is interesting, but we're not going to do it now. Use at least once delivery semantics. That's kind of like interesting to leave in. And implement item potent handlers for all events. That's pretty good, right? So I'm going to remove the the dead letter queues, and I'm going, see, and this is what I would like to do after the chat response comes back. I want to do this. Right now, I want to edit like what the LLM output. Right now, I have to go through a file, edit the file, and then put it back into the previous request and say like, look, this is your edited output. So that's why I think the chat modality is interesting, because it puts you into a certain flow that I think is very good. Like the rubber ducking, thinking you talk to someone is, I think, a mental mode that is nice to have and very productive. But also it just like makes you lose the understanding of what an LLM actually is, which is a string-to-string API, right? It's not like a thing you talk to. Scalability, each node type worker, blah, blah, blah. I don't care about that. Consider if, no, I don't care about that either. Use a robust pub/sub system is like use Watermill with Go pub/sub for now. For now, even doesn't matter all that much. So, and Watermill is like a Go library for doing event-driven stuff. So it just gives you like a nice consistent interface for publishers and handlers, and like a set of other patterns, which I won't get into, and then allows you to switch out the event queue without having to rewrite like 80% of your code. So, and the thing that I did right now is really, really interesting, because it had like way too much stuff to do. It had like words that are like not even relevant, or, you know, it says like Kafka and Redis and Postgres and MongoDB. And there's a good chance they will latch onto the wrong one, even though it's not what I wanted. So editing this is really kind of useful. And because I'm a Vim user, I can edit it really quickly. That was a joke. So anyway, we have this right now. I'm leaving the implementation consideration because that's like a nice separator. And the rest, I'm sure I could do the same kind of scalpel stuff. And this is maybe like already a little bit too much code for what I want. Because, for example, I don't think Watermill can do this like star matching that it did. Do I remember this correctly? I don't remember where this was, but it does this like, anyway, we'll see. Yeah, so this stuff I don't think you can do in Watermill, but we'll see how it does, right? So we're here, and then we're going to say in AMP code is going to say port the core of, no, port pocket flow to event driven Go following 01, and then, you know what, the other file here, this one, I'm just gonna delete it. I hope I deleted the right one. All right, cool. So I'm gonna go back to AMP code, and I'm gonna say like following 01 first draft instructions. I'm going to add a comma here. I'm just going to add 4 as well. So it looks like I'm fixing grammar, but actually I'm not. It's just like, it so happens that grammar is the way we put structure into our instructions as humans as well, into our communication. So here I'm just using that, but I could like use different weird symbols or emojis or whatever, which would make it clear as well. Punctuation and like these kinds of things are pretty important. So port pocket flow to design in Go, implement the test example, use mock LLM, and use a shared map as state store for now. I don't even know. I can be more ambitious. And I think it will come up with the right IDs and all of that. Use SQLite for shared state. Dot execution flow is not. See, this is where the edge comes in. That like I think I'm going to remove. It's probably already in the code for the orchestrator as well, right? It's like, does the orchestrator load the workflow from the flow registry? Oh yeah, because this is a generic orchestrator. Whatever, we'll leave it like that. This is interesting. Sometimes I like also like kind of dialing back my wish to control things too much. Actually, very often I just like let control to the LLM instead of being too precise. But this is like a significant difference, right? Like, do I encode the flow in the code or do I encode it as data in the code? And I think we'll revisit that. Like, I think it's going to do it as like data stored in the SQL database without giving me the tools to write stuff in the SQL database, and also have like no wish to save that into the database. So actually, yeah, just declare flow definitions in code declaratively, right? Like I'm repeating declaratively with just to make sure that it understands that this is about code style and not like the verb, or it's both, I guess. Yeah, I think I'm tempted to add even more funky stuff, but we'll do that in a follow-up step. I think this will one shot something that runs. Like we've now worked, right? Like all this preliminary work was to create this file that now I can be like a little bit more wasteful because I'm like, okay, go do the stuff, because this is actually tedious to do. And maybe you're not going to do it in as efficient a way as I would, but I know it's going to be doing it in a very efficient way now. And it's going to waste a few tool calls on like calling like go format or stuff like that, which, I could prompt it not to do and stuff, but also I'm fine paying those, even though they're expensive, because they're just going to waste like 50,000 tokens just to create a directory. But that's fine. That's fine with me, right? So I think this will be pretty good, right? Like I think the sequel is like this is not something that's going to be surviving the test of time all too much, I think. I don't know. On the other hand, it's good to roll with what the model comes up with and not constrain it too much. So if we look at the types, we have a base event type. We have a flow start requested, which has the flow definition ID and the initial shared data and the flow params. Then we have the final action of a flow being completed. We have a flow failed. That's good. We have a node prep requested with the node parameters. We have, yeah, this is all nice. It's not rocket science for sure. Then we have our interfaces. So this is interesting because Watermill gives you that. So the fact that it doesn't, we'll see if it does Watermill stuff. I'm curious. The state store is the standard store pattern. It's interesting that it does like interfaces all at once. I don't think I've seen that all too often, but it's like type definitions. So this is all good. Then it creates the SQLite store. Now that it has the interface, it just has to like implement that, and that will be easy to replace with like a shared map if we decide to. The flow orchestrator. So this is it going to, what is the flow registry? So it's keeping the flow registry pattern, but I hope that it allows us to do declarative flows in here. So that looks good. What is a flow definition? Is it defined somewhere else? Flow definition, which is just like the transitions are, this is like a little bit ugly, the map. But we can introduce string aliases later on, right? Like it doesn't make sense to redo the whole thing just because I want tape aliases, but also it doesn't make sense to also like send the agent at every file and say like replace with type aliases. I will just like either go in, change the type alias by hand, which is going to create linting errors, which will steer Cursor's tab model to the right place and just tab it. I might ask in the chat, because remember, the chat doesn't know what I do for the editing. So its output of the file, right? Like what I actually want to do is go back in here and just like basically edit this file at this place in the context window and just say like, look, magically you came up with type aliases. Like The model doesn't know better. There's a good chance that it would have come up with type aliases. It's like not rocket science, crazy thing out of the world. But now I am going to waste a significant amount of tokens to get these type aliases in there, even if I do it by hand, because suddenly then the file is going to be different than what is on disk. So the edit tools will not work. It will be confused by it output string, but now it's called something else. So I'm not going to do it now. I'm going to start editing code by hand once this AMP code run is done, right? If I start messing with it, I could ask the model to fix it and then it would know about it, but that's like further adding tokens. It's expensive because the longer the context window gets, the weirder the model gets, right? Like the higher the chance it is for me to spend a lot of tokens and get like nothing worth it in return because the context window is too degraded. So especially since you pay per token, that's like really important to remember, is that it's not just input tokens that are important. It's like how much in the terms of the quality you can still afford. Even if you're willing to pay the money, are you willing to pay like 4 times because it will get it wrong 3 parts of the time? Like, I don't know. And then I created a test program. That's great. I was expecting Sonnet 3.7 to do that. And AMP code really allows you to use 3.7 in like a constrained way where it manages to do still exactly what you ask it to, but also do it in like so full that it's like able to one-shot these huge things. So I don't know if I'm just making it up at this time, right? Because like at the end of the day, it's Claude doing this stuff. And there's only so much magic you can put into a system prompt. But I think there's also something about the prompt engineering, the tool definitions that I don't know, man. I think maybe I'm just like seeing patterns in clouds. And so the thing that I was most curious about is the watermill stuff. And so here we have a question node worker, which has an interface. We have a mock LLM client, which does like call nothing. Check if we have a predefined response. We have an in-memory flow registry. We have a SQL store. No, the floor. Okay, so this is the declarative part of it. Okay, cool. We have the watermill router, which looks pretty good, but then we have the setup, and then where's the run method? Because that one is always a little bit tricky. New router run. It adds the publishers. Then it does the setup, which you can only call once. And then started run. Okay, I think that will be good. It knows about the Go PubSub channel, Go channel PubSub. The flow orchestrator gets the stuff out of the flow registry, so we'll easily be able to move this to the database later on. So this is going to be very interesting. We have a test thing with like little emojis because it's Sonnet 3.7. And if we look at it, the interesting part is going to be we create the SQLite database, we create the new in-memory flow registry, we create the watermill router, create the watermill publisher, we create the flow orchestrator, we create the mock LLM client, we create the question node worker, the answer node worker, and then, so all of this stuff here, right? This is ugly as fuck. And that's what is so nice in Pocketflow, because that's like literally 3 lines of code in Pocketflow. So I don't think we'll be able to do it in 3 lines, but maybe we will to get this in declaratively. And so that's the once I run this, just to make sure that the code we have so far is like decent, I am going to ask AmpCode is next to make like a really nice declarative API for the flow definitions, which matches the Python pretty closely, but uses all the stuff we already have, right? So if I go into Go, and then I'm going to do Go mod tidy, and then I'm going to do Go run main Go, and as I expected, it works. But I don't know exactly what it's doing now because it should be running. I don't know how long it takes to compile from scratch. It should be saying us a little bit more. I think this is like a little bit silent. It looks like there's something that's not running, which I could totally imagine that like here it's not doing the right Go routines or something. I think it's running the cannot use. Oh no, say we're still compiling, so forget it. Then it says too many errors. So what we're going to say I wonder if I should look into this, but I'm just going to paste it in here, right? And here, I think all the context it has so far is mostly going to be useful, and I don't want to cut it up too much, and also I'm too lazy to cut it up too much, right? Like I'm totally willing to pay the like whatever 20 cents this is going to cost me to fix it like this, because that way I can talk to you, and that's worth 20 cents. So we'll see what it's thinking, and you know, maybe this is not good. Like maybe we're already going down a spiral of pain here. I don't know enough about what it put out to really determine. But what is it doing? Oh, does it need to do that in Go? So this is a Go quirk as well, I guess. I would have written it the same way the model did. So what is happening here? This is starting to be a little bit weird. We can't do the star, right? Like that. I mentioned that already. So we'll see what happens, because it didn't post a star. Node question, node answer. Okay, so this could maybe be a loop after that. This is stuff we can refactor, right? So I'm thinking about refactoring already, so that I can clock in at which point am I going to start that refactoring to leverage the LLM the most. Like if I do it too late, I will have more refactoring work to do. If I do it too early, I'm just going to spend like inferences that are now going to reread the files, and like I have to start a new chat and carry context over. So finding the right time to go in to fix which kinds of errors or like which kinds of changes you want to do is also, I mean, maybe I'm good at it, maybe not, because it's such a new skill, but it's something that I've been able to consistently get better at. Like, I think it's a very learnable thing where you do make progress, right? It's like the more you do it, the better you become at these things. But it's so new. Like I don't know if I'm bad at this. Like it could totally be that I'm missing like so much of what you. I'm sure I'm missing so much of what we can do, right? And so one thing I really wish is that instead of having this like, okay, we know how to build cursor, and we're going to build cursor for video, and we're going to build cursor for XYZ, and we're going to build cursor for that. It's like, well, do we even know that the cursor modality is like the best way to work with these models? Like I'm working against the grain already, while like working in Emacs and a buffer that you can edit and then sorry, I've got to ban some spammers. Actually, only people watching me. Yeah, the editing the file and then sending all of it or selections of it to the LLM, to me, is like a much more natural way of matching things. So sure. The one thing that Amcode is pretty good at, I think, is figuring out in which directory it is. But also, you can see in my shell, I always output the directory at the end. So that kind of helps some of the models figure out where they are. Because if they don't, then they will like just assume that they have to create files that already exist, and they will do like all kinds of weird shit. Which is why I always output this stuff. And then the UUID here is interesting. I wonder if that's from my shell, because I do save everything that's happening in my shell into a SQLite database, and I think they're written by UUID. I don't remember. What do I know? So why is it compiling so long? This is, oh no, so it's not running now, huh? All right, so this works. Cool. So we can see it has started, and then we can see the flow. It registered starting handler. I think this is maybe a good moment to stop also, because it is quite late. It's like I wanted to do 2 hours, not 3. I think this is a pretty good point to stop. And I mean, I don't know if I remember this, but I definitely want to have, actually, no, I know what I wanted to do. So I'm not sure if this runs. I think it gets stuck before running the router, which could very well be because that's a standard error with Watermill. It's like it will run, build this, start the router, build the router, and then it will create a background context. Oh no, see, it runs it in a Go routine. It wires up the signals, and then it does flow execution finished, flow execution started. So what I'm going to do, just for fun, is like add extensive zero log logging, set default level to debug, to help us debug, follow the flow, debug this, whatever. So that's one, right? Just to, I'm actually curious if this, to make this work properly. And the second step we're going to do, once we have this fixed, and you know, this is not too bad. It's just like adds logging, which is nice. I wonder if it found the wrong file. So this is where it stops. I didn't modify GoMod. What are you talking about? Why does it think I modified it? So if there's AMCode people looking or watching this later on, what happened here? I'll share the transcript. Yeah, and so I should tell it to like never do go run. Oh, that's funny. What are you doing, man? Oh, this, like, I've never seen it do that. Like, it does that per default. Anyway, this is weird, man. Why does it need to do its own colors? It does that anyway. All right. So here it's like there's different ways of logging stuff in Go, and it's like something that's pretty often like not fully consistent until your code base gets bigger. And when the code base gets bigger, there's bound to be like some logging line somewhere that it latches onto and understands what to do. But here we're starting fresh, and so it's possible that it just like doesn't get it. Why is this failing? So because we're pretty early in the process, and you know what? You know what? I think format on save and Go. What is going on? Like, why is this already failing so early? This is the one thing about AMCode that really, the last 2 days it's been, and I don't know if it's probably, I might have like set something stupid in here. Lint on save package. Yo. Format on save true. That's it. I knew I had added something. That explains all of it. Oh, what an idiot. All right. So because it has been reformatted, of course it has changed. So that is too bad. And that maybe that definitely explains all the shit I've been going through lately. So yeah, it was all my fault. I knew it. So let's try again. Because I'm not going to correct all that stuff, and I don't want to have like 15 failed to edit things in my history. Right? Because I'm going to pay per output token here. And why is it? Yeah, this is weird. The GoMod. I suspect that like GoMod tidy just like edits. Oh, obviously GoMod tidy edits it. Now it's creating a logger package. Okay. Sure. I don't. It is so weird. But it's a pattern that's pretty common in Go. So that is fine because it did indeed get modified. We were too late. Right, because it got tidied up between the last inference and now. And I haven't undone this formatting, right? I did disable the formatter, but I didn't undo its like misguided magic. And that's maybe something I should put into my instructions. Oh, because I haven't set up Go instructions in here. That's why. I was wondering, like, why is it not pulling in Zerolog? That's usually in my Go guidelines. It's because they're not here in the agent MD. All right. Yeah, I was wondering why it didn't use Zerolog. That's because I'm so used of having it here, right? Like I have my Go guidelines in the cursor settings, and I didn't copy them to the agent MD, which I usually do. So the agent MD, usually what I do is I just paste this in here and then I close it. So that's why we're wasting a lot of time here, just like adding stuff it should have added from the start, because I forgot. But it doesn't make sense to go all the way back, right? So like, oh, I made an error, like the top of this file is wrong. But that's annoying because I want to edit the top of this file, right? I don't, like, the top of the file has a very special meaning for LLMs. So anyway, it's not too bad here, but like, as you can see, we're just like wasting a lot of edit file tool calls. And I think I pay for them, right? I don't know how much I pay for them with the caching and how much they're doing, but like, this mistake is costing me money, and it might even be like $1 depending on how much I pay per tool call. And it's like, okay, too bad. I wonder if they do it per tool call or if it's just like streaming parse request and then it's not costing me. It's just like it looks like a tool call in the UI. I think I probably don't pay for editing file. Maybe it has edit file, doesn't it, as a tool? Are you making me pay an inference for just creating a file? I wonder, because you don't need to. Is it going to say that this changed on disk? Yeah, so this is not my fault right now, right? Because it hasn't changed. Wait for either flow completion or instruction. So why was it not able to? See, I suspect that it's the emojis. I suspect it's this. Yeah, it's most certainly is that. It's this one and it's this one here. That's a bug. Yeah, okay, so that's a real bug. That's good to flag, and I'm actually going to flag it here. Just while I'm at it so I don't forget. So this is a bug here, I think, the edit file tool. File tool cannot deal with Unicode emojis. All right. What was I doing? This one here. Okay, well, maybe it makes sense to not use emojis then. Here it was able to do it, but I think it has to do with emojis. What is the edit call? Oh, you can't see what the matching string is or not because I don't know, man. I think it has to do with this. How far are we in the stream right now? 243. So just to mark a note, reply. Oh, I'm going to create a thread. That's better. Create thread, 243, or like 240 in the stream. Note to self. All right. But I think we got our work done. Oh, it's still working. See, yeah, the adding the logger like that, forgetting to put in the Go guidelines and the agent MD is almost worth starting from scratch at this point, right? Because like depending on how they do tool calls and they build me for it, and I really wish I did, like I don't like, as much as I enjoy it being so opinionated, like please show me how much I'm spending. This actually matters to me. This actually really matters to me. Yeah, I can't just like burn money the way I am right now. Here I could totally say like, look, this was like $4 just fixing a Unicode thing or stuff like that. I can willingly, because if you go back at time, right, like the first inference is going to cost you way less. It's like way less tokens. And so it's doing the go run, which it also cannot seem to be handling correctly, I think, because this was like instant here, right? Except it's crashing all the time. So I don't know if I want to go fix this. Like I do have like a slightly weird taste about all of this. And I would like to watch this in peace. Runtime panic. So why is it panicking? Panic recovered and handler go, routine stack, debug stack, handle message, router, panic. And then the panic is the flow orchestrator line 30, but we don't know why it panicked. I was like handle flow start requested. That doesn't tell me much, huh? And was it always like that? Let's start again. Wait, is it that fast? That's the annoying thing with like fast programming languages. Okay. Holy shit. Why is it crashing? It's always crashing at the same line, right? I'm not going to fix that. I think this is too much of a rabbit hole. But however, that doesn't mean that what it created is useless, right? Like it doesn't work, but it's totally not useless. It's like a really good start. And what I'm really interested in, what will provide value, is make a nice, concise builder API for creating a declarative flow to be close to the Python version of Pocket Flow, right? And I don't know if I should link a file, but since I know the name of the file, it's going to be in flow MDC. No, it's going to be in readme.md. I think flow MDC has like an explanation of the syntax. So we're going to use that. I think C is kind of important for M code. So even though it doesn't work, the API will be correct. Like if I designed this well, code written with the API in mind is going to be good code, right? And here I want to iterate on the API until I find an API that I know is going to be implementable. Like it's totally possible it will come up with something that's like not possible to implement or like weird to implement. But this is going to be very useful and very cheap, and it doesn't even need to work, right? Like on the other hand, figuring out like a crash because maybe it's like we initialized Watermill in the wrong way or stuff like that, that's going to be painful. It struggled with Watermill quite a bit as far as, did it? Actually, I don't know. But so figuring this one out is going to be potentially something that I don't want to get into here. So it's flow orchestrator line 30. See, my ADHD is too bad. It's like line 30. I thought it was the storage, the store shared data. So it's possible that the store is like not good. So what you can do while Ancode is running, right? Since this is a file that will probably not edit too much, is I can start editing it to just add logging. In the worst case, if it starts to like edit it at the same time, we'll like undo stuff. It's the first time I edit files that are so close together. So we'll see. Usually I have like, oh, one is going to work on the Python, the other one's going to work on the Go. Here, kind of interested what's going to be happening here. I see we already have a flow builder. No, it created the flow builder up here, right? Yeah, okay. So I hope that we come out, I hope that it knows enough Go and is clever enough to come up with a really nice API. Usually the LLMs are. Like usually I kind of like the APIs that they come up with. And so this is still generating, but that allows us to basically save time, right? For the potential danger that this is going to cause this to fail, and then we'll have to spend more tokens to kind of repair it. But it would be like a fun thing, right? Like if you consider this to have like fragments of files or like full files in there, it's like if I edit them on the right, there's no reason they couldn't be edited in the chat itself to just say like, well, it seems like magically you keep coming up with the right tokens for your files, right? That kind of means like the next time I kickstart an inference, it doesn't need to reread stuff. It's like it has been edited and it's sync. Or other things you could do is if you create a file, right, like here, and then the model outputs another edit tool file to modify the file again, and then once more, and then once more, you might as well just like collapse that into one big edit and say like, yo, no need to repeat like a before and an after string all the time. So let's create a simple example with the flow builder. Come on, is this going to be pretty? Yeah. See, this looks pretty nice. And so here it's crashing probably because of the store. That I'm not going to do tonight. I wonder if this is going to compile though. Like how crazy were the errors? How can I see them? Oh my God, come on. What are you doing? No new variable. Yeah, that's cool. That's all like stupid Go stuff. It's weird that it does like such Go-ish errors tonight, where it's like, also, did it change anything here? Like, what the fuck did it do here? Oh, it changed the type. All right. So here I feel that there's like a bunch of things that are, wrong in this like LLM bad way, where you kind of need to know what's going on to actually figure out that it's wrong. But also I know it's eminently like fixable. And why did this go wrong? Found multiple matches. Okay. I swear I'm paying for all of this shit. Which is fine, but I do need to know. It does determine my prompting if I try to do this, or like how careful I am with editing files at the same time and stuff like that. Like those things do matter to me. If I know that like me editing a file on the right might potentially cost me $2, then maybe I'll wait, and if it doesn't, then why would I wait then, right? Or like fixing these kinds of things. That's why I want to have like an auto format. The auto format could just like, depending how things are and where the inference is right now, right? It could be like either injecting stuff into the token stream to say, like, that really depends on the modality of the provider. But if you're running your own local models, I can insert and say like, yeah, I did it. Like, don't, right? Like auto resolving the tool call that comes in. I don't know exactly how to do it. And then this doesn't output any tokens, which is good because it's doing a lot of garbage. So it didn't fix this. I think this is broken because of the flow orchestrator line 37. What is going on line 37? That's really for another day. Whoops. Oh shit. Yeah, please accept all of this. This is great. And I didn't see it. Accept. Where's my accept file? Is that gone now? Huh. UI bug. Control Y. I'm clicking. Does Control Y work? No, what the fuck? All right. So it added logging to Flow Orchestrator. And then Flow Orchestrator store shared data. So here it doesn't have like the state store. I'm sure the state store is nil. And the new Flow Orchestrator is being called with this. Where's this being called from? It's being called from here. And then, wait, what happened to the cursor? New Flow Orchestrator, state store. State store is being created over here by the new SQLite state store. Interesting. So here as well, I'm going to add a lot of logging. Add lots of zero log logging to help debug. And we're just going to use I never use 4.1, but people have said that it's really fast, and it is really fast. All right, cool. Why am I debugging this? I said I wouldn't fix it, but I am fixing it. Did it rewrite our main.go to use the new builder pattern? I don't think it did, huh? Now let's add the flow node worker. Is it using the new flow? Did I not pay attention? Main.go. And it's creating the flow. Where's the flow? Oh, it's here. Answer node, and then the node worker, node workers. Create node definitions, and then event new flow, then this, then that. Okay, it's not that super elegant, but it's not that bad either. Like the flow itself is actually pretty nice, right? And then the answer node def. Do we have like other routes? Isn't there stuff missing here? I think I'm getting tired as well. So we will look at this another day, just so I can rest my brain a little bit. Where's the dispatch done? So anyway, let's look at the example that it created. That was maybe like a little bit nicer here. And the type annotations don't make this like more easy to read, but you have a review payment revise node, and then the expense flow starts the review node, and then the review node to approved goes to the payment node, and then the needs revision from the review goes there, and then it goes there, and then it goes there, and it goes there. And then can you say set current back node to here? Can the other flows do other things? I wonder how this is implemented. This is like a little bit weird. Name transaction, new node, then. Yeah, I think this we might want to have something that's a little bit more. I don't think this is the best API, actually. I don't think this works either. Current node, so it has a current node. How do we change the current node? Here's the current node, transitions. So it's done at the end of then. So this is wrong, right? Because these would be review needs revision, but however here it's like the on is payment node. So this API is garbage, and in this case, I would actually entirely go back and and redo this, because the API doesn't work. And so instead of having it do the whole API as it does here, right, which is a lot of token, a lot of cool. So just write a file ttam 051502. It's go flow declarative DSL examples, that DSL definition and examples.md. Maybe guide is better than definition. Guide with examples. And it's a markdown, right? So it says, it knows that it's going to write code, but inside a file that describes the builder API and gives a bunch of interesting examples. So I hope that if I regenerate that, it's going to do a decent job again. Because there's no way I can salvage all of this stuff, right? And I hope that it hasn't reverted what I did in here. No, it hasn't. Very good. I wonder if I reverse the diffs. And so now it's creating this file that then I can modify this file on its own without needing to have this entire conversation that I have here, which is at like 80,000 tokens now or something, like 100,000. Like this is too long already, right? But this was the 100,000 tokens of all the stuff I deleted now. I think this updates after the inference is finished. So we'll see. I would suspect that we're at around 60K, but that's just like gut feeling. Man, this is so addictive because like, yeah, it's been 3 hours. I really need to set some time limits on this stuff. Because I've been at it since like 7 a.m. So I need to take a break at some point. All right, and this we can look at in peace and say like, well, does this API, does it even work, right? And the other one I could see, well, this API, I can't even make it work. And so the begin is actually the better way to do it, right? It's like begin and then, can you do begin multiple times? This is weird too. From. Loop back. Oh, so this is the default, but then, yeah, I wonder if I need to tell it like, oh, when you do on and then, the current node, when does it get changed, right? It's like the begin is probably not. I don't know. Is it begin? Build a pattern. Uses chaining. Begin question node, then answer node. I don't even know what that means. Equivalent to this. Okay, so equivalent to node A, action name A, but no, it has more, right? So the funny things you can do here, right? It's like equivalent to, and then say node A, action 1, node B, and then node A, because that's the thing, I'm not sure how to, it's confusing in the API already, which makes it not a good API. Because if it's confusing at the word level, then it will confuse LLMs working for it, right? So that's why I want to have, as I design my API, I think not just about humans, so like, that's elegant. I'm thinking about, okay, will LLMs be able to understand what is going on? And sadly, it means often that things are a little bit too verbose for our refined developer tastes, right? And I'm going to add some more here. Action 2 goes to node C, and then node D. Action 4 goes to node A. I am just making up some stuff here. And this is potentially something I could generate with an LLM or use all the examples from Pocketflow. See, I was telling, I thought we were like around 60 tokens, 60,000. We're like 70,000, 80,000. So close. Oh, we did generate a lot of code that we threw away. I'm sure that was not cheap. So yeah, that's the one thing. Like, I think people should think about how much it costs because it makes them better prompt engineers. So this is a display bug, but I realized that it doesn't break the Python. So what does this look like? So you do begin. Okay, so from node B. So why is it begin node A but then from? Shouldn't it just be like from? Do we need to begin? Am I going to waste 60,000 tokens of just to ask a stupid question? I don't think we do. So why is it? Yeah, because this is nice. Like, I like that, right? Like, this is how I want to write my stuff. And this is also something that an LLM probably will be pretty good at, even if I just have this file, right? Like if I go to the chat here, a GPT-4o only knows the context of this file of 02 go flow. And now I can say like, write the declaration of an agent that does deep research and can send emails. And hopefully this thing does know what deep research is and how it does it. And then it like literally writes the whole agent and you can, done. since it's pretty good at prompt engineering and stuff, right? Like this way you can, having a good declarative API and definition allows you to just like one shot, and it doesn't even look like you're one shotting. Like sure, of course it works. But right, it's like it goes from search back to research node, and it goes from synthesize back to research node, and then the research node will probably say like, oh, when you're done, email. So you're a research agent given a query, decided to search the web, synthesize information, send an email with your finding, and then email is at the end. So this is kind of like a shitty prompt. If we switch the model, right, because now it's so cheap to completely change programs all at once, right? My whole agent, I don't need some kind of like lang whatever JSON declaration or so. It's like if you have a good code API, you can program entire programs in one tiny little inference, and you know the program can't even do like broken things because the API doesn't allow it to do broken things, right? So if I look at this, there's no way I can express a graph that does something worse than doing an infinite loop, because it will like not try to open files or like connect to the database or whatever. It's like literally just one little declarative line of code, right? And so if I look at what Gemini, what Sonnet 3.7 came up with, like a creative little in-house genius, Anthropic models are pretty good at prompt engineering, so that I always enjoy, right? It's like they do these like big ass prompts. No, in this case not, but it does our search planning or query analysis. So this one has like a ton of little nodes. And if we look, however, the declaration of the whole thing is that we go to a query analysis, and we go to search planning, and then we go to there, and does it actually loop back? It goes back to search planning, right? On continue research. So I'm not sure if this is weird. So I'm going to modify it. So like, I'm just going to go back because I actually don't want this in the file. No file editing, please. Make one which loops and does dynamic planning. No, not dynamic planning, and does refinement of a plan. Because what would be interesting in the one thing that this framework doesn't allow you to do is add new edges and graphs as you go. I mean, it probably is able to do that, but it's not like designed with that in mind. And so that's going to be interesting to see if that even makes sense or not for the kind of agents that are easily expressible in that manner, right? Like, because it doesn't mean that like this API should support every kind of agent out there. It should support a certain type of agent, which is something that can be described with like declarative graphs, which is by no means how you deal with like ultimately just a magic API that gives you back a string when you give it a string. So we have our different nodes. Then we have the research flow is like goes from career analysis to planning, then web search, then content analysis, then needs more research going to planning refinement node, then back to web search. So that is pretty nice. Sufficient info synthesis node, then email node. And so this way you can like start to build it out a little bit more, right? It's like after synthesis, have a critique step that might just redirect it to refine the plan. And then you can start just modifying your program basically just like that, right? And that is pretty amazing. When you have a good API, right? Like you can just literally say like, well, please add this. And you know it's easy to write by hand, but it's like even easier to say it. So one thing I can see with this flow builder is like, we can store it in a variable and like start like building it up multiple times. So maybe it makes sense from the composing to have like additional functions that could be like, oh, cycle, or not because it's shorter to write, but because the word cycle is less error prone than this, right? So it might even make sense to say, oh, there's an alias for then that's called like back to, because it reads nicely to have back to, even though the implementation doesn't do anything. It's just like more robust for the LLM to understand that here there's a cycle, right? So we can say like introduce back to as an alias for then, which you can also use. And then Is there anything else that we could do to make this more readable? No. But you will see this makes it not just also more readable for us, right? Like it did do a little bit of the readability through the formatting, but now we really have a word that allows it to like, oh, if we need more research, then go back to planning refinement node and then this. That is just like more elegant, right? Needs more research. And even though it's completely an alias, that just makes the API more robust for LLM generation. Begin is where the flow starts, so it does make sense to have it as a word build. So yeah, I really like this API. I think this is as elegant as we can get in Go compared to the Python. And compared to the Python, which has like minus and like bigger, this one has real words in it, right? So say like beginning from the query analysis mode, we then go to planning, and then we go to web search, and then content analysis. But when content analysis says needs more research, we go back to plan refinement node and then do a web search. Like that's just like super nicely written out. You could almost like remove the parens and have like real English, and that's good, because they are trained on real English in their majority, right? Anyway, that's enough for the stream, and yeah, have fun.